hydration critical. Stop shrimping, streamer man. Time for a big stretch.
Well, hello. So many demands so early. Well, fine. I'll start with the hydrate. Hello there, Cinnamon and Win. Hope you're doing well. We'll hydrate with the good old coffee. Oh, delicious. And hello there, Real Zamir. Oh. There we go. Let's go do a good stretch then. Over the shoulders. And in the back. And the second round. Oh, there we go. Yeah. There we go. And then the back. Touch your toes. And then the second. Thank you. A lovely and refreshing way to start the day. So, I need to organize my cable madness at some point. Oh, and if you haven't done it yet, then you still need to do it. Remember, kids, take your meds. Lovely. Now, I'm going to move you to the side. We'll open up Windows Media Player so it's ready for when we need it. And might as well open up Godot so it's ready in the background, and then we'll open up Krita, and then we'll do a little plan for we'll plan on what are we doing today. And at some point I should also update the Godot game engine. Yeah, before we make the game too complex. Not that that'll happen in the near future. Check here on the... There, add the complete shuffling of the shuffles. Interesting. Wow. Any fast takes a while. I guess I got too much crap on my computer. That's okay. Well, Godot does what Godot does. We'll switch here and to this scene. Whoop, bam. We create to activate. We jump here. No. Yes. Into the pages of the DIY Wizard, which is the game we're working on currently, and we with a keyboard with its broken buttons forward. I still haven't gotten around to buying the new one. Got the money for it. More than earmarked. There we go. Yes, thank you. Windows for the beepity boops. So, last time we got we have the main character. You can move around. We can launch attacks. And there's a little red cube we can attack. That will register those attacks. We started working on what will be the logical structure of the runes and the circles that will be then used to create the attacks, which is the sort of core mechanic in the game. So we guess now we're going to use these 2 hours to figure out next steps. So how does the logic actually work? Now, we do it last time, so we have our your basic rune circle. We'll have your 3 nodes. One leads to the other. Like I said, so it's visually represented the player like that. But in practice, it is 3 nodes, each leading to the next one. So we have power source, filter, and projection. This is the most simple one we're going to start with. So how does this work then in code? WYY, whiz it yourself? Doesn't sound right. Spell it yourself sounds more of a typing style game. Very true. Yeah, the DIY wizard is currently just, temporary name. We'll come up with something better at some point. I just needed something to name the files. And, something like Spellcrafter, that sounds like it's most likely taken. So we're gonna come something like, artisanal magic or something. Rune crafter, freaking rune lord, edgelord, rune edger. Edging them runes. We'll come up with a name eventually. Right now we're gonna focus on mechanics. So as mechanics works, then we'll start looking into things like, art, animation, names, settings, making the actual game out of it. But for me, what I want to start with is getting the mechanical engine beneath everything to work and be as sort of modular as possible, so that we can then see where the growth of the game takes us. Because the original idea is I'm trying to keep it as simple as possible and as modular as possible. Also, because I do know many creative projects, if not all, they eventually have to do some kind of pivot. So I'm sort of trying to preempt that by, like I said, trying to make things as sort of modular as possible. We start with these like base components, so that if we then we in our testing notice that the original idea will hopefully be fun, but what if there's this other thing we just suddenly realized was actually even more fun? And then, well, let's pivot into this new shape instead. So we start with our Vampire Survivors like top-down shooter, enemies come in waves kind of thing. Who knows where this will take us? And also, I like the concept that I want to experiment with here, which is the sort of runic circle and having interchangeable parts inside its own like logical structures. It's essentially a crafting system, and essentially because you could have those nested, you can have a lot of like a runic circle inside a runic circle, and from that we can go into all kind of like magical engineering kind of things, which is sort of where the idea originally came from, was trying to figure out like how could we do like runic circle magic in something like, say, Dwarf Fortress or like Minecraft, and then, well, you'd have these things here, and then they would react, they would detect each other, and so on. But in this one, instead of like you placing the runes inside a 3-dimensional space, you're giving a pre-made sort of circle. And who knows, maybe I will then eventually push this idea into that 3-dimensional space. But this will be the first iteration of just, testing the idea. And who knows, maybe it'll turn out that this is interesting project, but it turns out to not be a very fun game. Well, then we'll make something else. Because, well, I want to make games. I want to make a game some other people would enjoy. And doing it on stream is a good way to make sure I get at least some of it done. Okay, so let's go back to what we were talking about here. So we have our first like logical containers. So I'm trying to like just wrap my head around what is the actual sort of like hierarchy. What is the what is the flow of information here? So your most basic one will be the rune. Now the rune itself will then be inside a container. So we'll have like, I don't know, we'll use a brown one because why not? And inside is the R for the rune. And depending on what kind of rune is there, it'll do different things in its, as a part of this if this then that sort of logical string. And I've never built anything like this. For anyone else who's made something like this, I know my struggles might seem a little simplistic. But hey, that's why we're here, to learn. And for you to watch me struggle. Now the rune will then have, in our most basic form, 3 sub-forms. We have our power source. I was playing My Winter Car yesterday on stream. It was fun. Neat game. But it is one of those where because then this morning I had to go to the store. Which meant I had to then do My Winter Car in real life, get the block heater on in time, because the real ones have a timer, so I had to and I hadn't plugged in the car yesterday because it's been quite a few days since we drove anywhere. So I had to go plug it in and brush off the snow, which there was a bunch of, and start scraping off ice what I could. Then get inside and wait for the block heater to heat up, warm up the car. I have a small heater inside the car which detects if the block heater is on, and when it's on, it also then tries to warm up the inside air, which did help, but sadly, a few days back, apparently, we've been too close to 0, so my side windows had not just frost on them, which normally is relatively easy to scrape off, it actual ice, which was much more difficult to scrape off. So. And it's funny, I heard a casual mention today that, that's apparently someone else in chat was saying the same thing that what I've said, that apparently, there's multiple Northerners now that are saying My Winter Car looks cool, but it's too real. We'll wait for it to summer. So now we're going to play My Summer Car during the winter and My Winter Car during the summer. But nah, I'll be playing more about My Winter Car. If nothing else, maybe I'll do my own My Winter Mondays, which for a lot of Americans, I guess, is Sunday evening.
Just keep the doors inside. Problem solved.
It's true, I guess. Remove the doors from the car, put them inside the house, and they'll melt. And then when you need to go somewhere, that's when you reinstall them. God damn it, Discount. You're a genius. And how are you doing, by the way? Nice seeing you. Yeah, so we have a couple of days of this one, a couple of hours of this, and then it is back to Europa. So this is our logic structure here. We have the runic circle. Good morning. Hey, good morning to you as well, my friend. Yeah, we're working on the DIY Wizard, my first long-term game. Well, my second attempt, I realized. I sort of forgot that I tried to do this once already. And a long-term game project, which is a top-down Vampire Survivors where instead of, you kill monsters, you get points, and then you buy something in a store between levels, like in Rotato, or in Vampire Survivors or Megabonk, where, you find these chests and you gamble for random possible upgrades. The idea is to then use some sort of points system and discovery to give you these runes and rune circles. So I guess it'll be closer to Rotato in that way. And then it is up to the player to build their own weapon. So now I'm doing the most basic 3 rune circle, and the idea is as the game progresses, you'll have access to more complex circles, which allows you to make more complex logical structures of if this then that kind of thing. So we'll have our most basic 3-point system, what we want to design first, and then from there add more, complexity. So the starter runes would be the very first thing we start with. We need one that is a power source, which will, in our testing, will just push out unattuned magic, because in the future we'll then have different kind of power sources that might be pre-filtered and so on. So we first start with a power source, a filtration, because it is unfiltered, just raw magic, sucked in from ambient magical energy from the air. And then it goes through a filter to which decide you know what I want, but I only want the fire magic from this one because I want to make a firebolt. So we then have a filtration, so a filter rune, and then lastly that sends the filter magic forward to the last one, which creates the attack itself, which defines its shape. So are we doing a bolt, a beam, an area of effect, an explosion, what? So we'll start with those. And I mean, so by calling out called the, I don't know, it determines its. For some reason, my brain keeps on going to extrudable. We'll keep on calling it like projection for now. We'll come up with more better names. More better. Indeed. So these are the basic forms of rune. So which means, what do they all have in common? Well, they have a name. They have a type. But outside of that, they do different things. Because I'm trying to think of what is the sort of class structure we're doing here. Like, should they be like your base class for runes, and inside that we have a piece of code that then constructs the rest of the rune from other things. The power multiplier, exactly that kind of stuff. But right now we're gonna just do a basic one where the idea is because then what the filter does is, so let's say we have we're gonna start with our the 4 classic elements of air, fire, water, earth, air kind of thing. Now, if your basic unattuned magic is equally made of everything, so it's like 25% of everything, and we only want the fire, that means then we have 75% of the power still left in here. So the idea is the excess is then dealt with by the sort of runic circle magic itself, and that determines the cooldown between your attacks. So that's the sort of idea I was thinking of here. So you have then, eventually we'll have different, more complex, more nuanced forms of runes eventually, where you then, depending on how the player designs their magic, it'll have, the efficiency of your design determines like the cooldown and so on. But you can do like a raw blaster that puts out like heavy attacks, but then it also causes a lot of waste essentially, which then causes more a larger cooldown. So essentially, having a bigger power source will give you a bigger bang, but also a bigger cooldown. And I'm hoping, for this to eventually become more complex. But I never built anything like this, so that's why, currently I'm just trying to sort of build my head around what is the sort of class structure for the object-oriented stuff in my coding here. Like, do I want a sort of base rune class, which I think we do, and then from that we extend into different classes, and we'll have like power sources, filtration runes, and then projection runes, which in the beginning will just be your generic filter, brings only this element forth. 100% of X. Projection then turns it into an attack. Because once I just get the sort of like logical structure fitting in my head, then we can add more nuance later on. And especially if I get all of these to fit inside like proper resource files, because then we can build runes outside of Godot and so on, essentially. So a rune will always have a base class, will have a name, a type, and a sprite, because it needs to be represented somehow. So a minimum of those, maybe even no. Yeah, because when we want a visual UI where the player will be like click and drag runes from their library or something on one side into the circle we see. And yeah, like my basic one is like I drew here. It's only has 3 nodes, and it'll look like a circle, but effectively it goes like step 1, step 2, step 3, and then goes back to the beginning and just loops through this, and deal with cooldown, do the thing again. Hey there, Krillin Air. Happy New Year to you as well, my friend. Hope you're doing well. And if we look at my sort of older, because then we can add more complexity in the rune circles, and then the player could maybe choose which of these lines is active. So we can have certain things output to multiple runes at the same time, or it can, depending on like a certain trigger or something, only one of these outputs is used. So that way we can have more modular, more complex behavior inside a simpler sort of design here. That's sort of the idea here that I'm playing with. We'll see how it works that one. Is that a pentagram? Technically it's a pentacle because of the orientation. But yeah, because the idea was just to show how you can have multiple connections in a relatively simple geometric shape So that would be, yes, the 5-pointed star, but you can also have 6-pointed, 7-pointed, and so forth. Or like a square. Well, a square and a circle won't work because they'll all go through the same. But you could put in, say, a triangle there and so forth. And then we can come up with more esoteric designs. Try to make it look all neat eventually. Maybe we would add some form of adding lines through the circle between nodes that the player themselves can draw. Could be fun. But we first have to make the most simplistic form function to function, which would be this one. So what exactly is the class structure? The basic forms. Now, have a happy week after the new year. Happy week after the new year to you as well, Krillionaire. Now this rune would then have in its base class, so we do a rune base class contains a minimum of what's the rune called? Name. We can't call it that because name is taken in Godot. So go like rune name. There you go. Because the node itself will have its own name. We can't just call that one name. So rune name to differentiate, unless of course we do. No, it'll be fine. And then we have, because there will be the different types of runes. So these are the like three we're starting with. Most likely we'll then have, like Discount pointed out, that we can have like power multipliers and so on. So we can have more runes. That's what we want, a sort of simple, easily reusable like base class from which we can then extend to the other different classes of runes, and then from those we can then create the individual runes. And that is why we need to have these sort of what do they all share? Well, they all share a name. We could have inside here also an integer that handles which type it is, so we can quickly check from there. We can save that as an enum, which all these names, and that way we don't, when we check, we can declare like, okay, make rune of this type, then that we change that enum, and then we, based on that, use a function to, make this. Type. Or should we just use that as a naming convention? All these are just called rune name, rune type. That could be good. Because again, you might have seen me how I write my stuff also in the IC10 inside Stationeers. I like things to be sort of as natural language as possible, because I am very forgetful and easily distracted, and I realize if I don't name things as obviously as possible, when I return to this bit of code later on, I have no idea what the fuck's going on. And then I need to like sit there and like figure out like, wait, what, this leads to here and that does that, and then okay, now I see it again. But if it's all like just spelled out, I'm like, oh, all right then, noise. There we go. So I'm gonna just take the spoon out. Nom. Weird tasting coffee. And I guess this might as well also be called then rune sprite, because in the UI it needs to be represented by something. And color might be able to separate them, like red fire, blue fire. That is very true, but I was thinking that would then be determined by exactly the color of that comes after the filter. So the rune itself doesn't care, because the color for the elemental sort of coloration would come post filtration kind of thing. Or then filter itself would have some special color information. But yeah, the idea is to then that we want to then use all this information we're gathering here as we then create the attack to sort of procedurally generate the animation. Currently, I just have these simple fire animations I'm using for a bolt. And the good thing is I have a little pre-made assets, and they come in like 4 different colors or so. So we can use those for testing. Eventually we'll make more art, and then we can, like there, we can then have, either we do multiple different assets for the different attack types, elements. You know what? No, I think it might be, we'll have to then eventually look into the option, because Godot has the modulation value. So we can do RGB and change the color of a thing. So if we have, say, all our attacks be first made as sort of white, for example, and then depending on the elemental balance of the attack itself, it'll then modulate to fit that. So eventually I was thinking we'll have efficient and inefficient filtration, where you want the fire, but it gets a little of the unattuned magic in there, and then messes this up and doesn't get that. It's not like a perfect filter. Eventually then you have perfect filter that's only fire and it's like a pure red attack. But then the other colors get mixed in because there's unattuned one, and then it goes more slightly grayish or something. And that is the sort of idea I'm sort of trying to aim for here. Oh, sorry. But but these are the rune base classes simply that has, I was thinking there aren't that many variables at all. Runes have to share. Hey there, Coffee Then Code. Nice to see you. Hope you're doing well, my friend. I'm finally starting, this week started my long-term game project. Now so you got to figure out my sort of rune magic circle logic here. Yeah, but if you look at the video, look at our attack here, because see, I have this animation, and we have these in different colors. So currently I only saved into, see, we got about 3. We got our yellow fire, blue fire, and red fire. So the idea is to in our testing, we're just going to use these. They're still purple and green, I think. I am spent 15 hours in the last caretaker before even leaving the starting building. Hey, nice. Yeah, I mean, that game looks really cool. It is something I really want to try, but at the same time, there's so many games that keep on pulling me in. Oh wow, another game design stream. Nice. Hey, Ganatank, how you doing? Has a demo. I know it has a demo. That doesn't mean it's just have a taste. Just have a taste, No, the first one's free. Yeah, no. I think I even have the demo. But I realized we didn't need to wait on that one. Yeah. Ooh, 5 Steam streak. Yeah, thank you, Gunattack. Thank you very much. I do appreciate it. But yeah, we're going to try to do game dev streams now, hopefully every day. Every now and then I might have to today we're just going to be playing. Or then we'll do one entire day of just game dev. But I'm trying to do a minimum of 2 hours per day. You'll like it. It'll make it nice. Yeah. But now I'm trying to come up with first the most base class for my runic magic game here. So yeah, so yesterday we got a super simple thing just for testing to kind of work. And then we'll have, I think this is pretty much what the most basics of what the base class needs to contain. And then from here we'll then have constructors, I guess. But that'll be functions then. Where man, I need to look into the whole, how does the so when we grab from a resource file the information that we've determined that a rune will have, and the game needs to create it, grabs from there the name, type, and sprite, then based on the type, it does a different kind of constructor to then build it as a power source filter or projection rune. I'm assuming. Man. I was wondering, does this need to be a script or could it be a resource file? I can't remember how all the resource files worked in this goddamn game. I don't think they can have functions. They can have all this information. So this will be for the base class that actually constructs the rune. But for what? When do we construct the rune? When it exists, when the player has it in its inventory. We don't need to have all the runes in their inventory, only the ones they have. And then we'll generate them from a list when they need to, when there's a store, however they gave the player gets more. And then those will be then loaded in as necessary from the resource files we have. I think that might make sense. So we'll, yeah, coding in a kit bashing style. There we go, coffee's gone. Now the power source needs stuff. Now what does the power source need? Well, it needs an input and an output. Output would be just give the information. Hey, hello there, Kim Stockholm. Good morning to you. I hope the day is starting out well. So the class here needs an input and an output. So how do we get the input? Does it fetch it from somewhere? Is something feeding it into the function? Oh, god dang it. We need to open a new layer again. Because this means we need to then have a look at just the logical flow here. So if we have, say, the power source function here, and it has its input, then we have the filtration room here. That's the output's input for the filtration, and same for that one into the projection. Well, kinda. I'm on my way home to sleep. I'm the night watch. Well, I hope it was a pleasant enough evening, and I hope you have a good sleep when you get home, my friend. Beneath this one needs two outputs. Because this one also then generates this sort of waste heat, effectively. And the magic we want to send to the thing that creates the attack itself, the bolt, determines the shape, deals with what we give to it. So this generates the attack, calls it from the attack manager, essentially. Hey there, Lions Man, how are you doing? Holy butt nuggets, goddamn 40 stream streak. Oh, you madman. Thank you very much. And I hope you had a good time today in Shrouded. And I hope you're doing well in general. But now we're gonna design this one. So we're gonna... Now the question is...
You're welcome.
No, thank you. Let's go! Nice. Now... The power sources will have the different types. So one of them will be, I was thinking we'd have essentially ammo for the attacks. They'll be like magic crystals. You get them from defeating enemies. And some of them might be like elementally aligned. So you have like fire, like crystals. And that way it's already mostly pre-filtered. So using that as the power source will make you get more power out of a cheaper filter kind of thing. So it has an input of some sort. It'll need its own slot. Maybe it'll then depend on like some circles have that extra slot for like an ammo input. Could work. But the one we're doing now just have here, so it's a passive power source where it just sucks in magic from the air. So its input is technically just a solid number. So For our testing, it's a constant input. And then it has output to the next rune. But how do they know about each other? How does all this happen? Which needs all these, and where does the output for the cooldown go? Well, all that we need to think about what is the logic behind the magic circle itself. Because the circle would be the one who has to then call these, deal with the runes. So maybe we can't do it like this, but more of a, it goes to the circle, and it goes to the next one, goes back to the circle, goes back to the next one, and returns to the circle. So the circle manages, it does everything. It checks the runes for what's happening here, because the runes themselves shouldn't care about where they are, who has it. They just do a thing, like a machine. You give them something, they do the thing, and then they pop out, spew out their output. And then I think that could work. I'm good. Needed a little time for myself. For going back to work in 2 weeks. Ooh. Well, I hope the time for yourself goes well. It's always good to have some me time, have a little time to chillax and relax, and I hope work goes well. Yeah, because this would make sense, because then we don't need a separate like 2 outputs. It'll just have its, yeah. So this way we have the nodes. There's an input, which in this one our testing, that will just be a constant number that the rune itself is generating. We'll worry about the details of how this one works eventually. And this way, they all send their information back and forth to the parent here, which is the circle itself. Effectively our rune manager. Now what does it do? Does it care about in which order the runes are? I guess it'll have to detect which one is the power source, or we'll start by building it in a way where the power source has its like defined position. Because I'm thinking, like, if they go in a circle and I want the player to be able to place them in multiple places. So what determines where does a circle begin its flow? Well, for logic to work, it needs to have a beginning, a determined beginning. Because we could visually make it look like the player can choose where it starts from, but effectively it's always doing the same. We're just shuffling the array around in which order they are. So there's always start from 0, head to end. So the circle knows where the first rune is, and it starts from that one. Which, if so, yeah, I just said it. Effectively, it has an array of runes. How they're visually represented will be also do the circle manager. I guess we'll have to do that one too or something. We'll get there. The circle knows where the first rune is by knowing where the first rune isn't. That's very true. That is exactly how it all works. The word knows that the very first rune is an absolute 0. That's where we always begin. I think you must have enacted the ice rune. We have light snow here. Bump, bump, bump. We have real snow here as well. I mean, it's relatively light, but it's like it was minus 17 degrees Celsius outside. And apparently, since I last drove my car, it's been close enough to 0, so it was covered in enough moisture to have actual ice on the side windows, which made scraping it was very annoying this morning when we went to the store. But yeah, that's one of the things why I understand people excited about my winter car, but as you know, as northerners, it's a little uncomfortably like realistic. It's like, oh cool, I can now live the misery of real life in both in my games and outside the door. Lovely. Still fun. It's still a pretty fun game though. So we will be returning to that. Like I said, we'll probably do like my winter Mondays or something for a while. Speaking of which, I really should make an actual schedule. I should know. Again, Stationeers has just eaten my brain. Now the circle would then normally, so we go to rune in rune slot 0, but the circle shouldn't care about what rune is where. So I guess we'll have some sort of like current spell state array or something. And it's sending that to the rune, and the rune does something with it, and the rune sends it back. And then it sends to the next one, rune does something with it, sends it back. Then goes to the last one, rune does something, and it sends it back again, and then we loop, and then depending on, after all this, the circle looks at the waste that's left in the array and creates a its cooldown value, waits for that to be over, and then it begins again. So, which means we'll have a sort of a I think that might be the most logical way to do this. Because this way, you can build a completely non-functional runic circle. What are the metrics of the attack? Presumable, the endpoints. The idea for the attack is currently our attack manager that we have in the game. It will look at the information it is being given and generate an attack, and it's off. I'm hoping to eventually then add maybe like there's a certain spell state we can also then tie into the attack. Like for example, does it have a special effect it has as its endpoint? Currently we're just determining its elemental structure, its damage, possibly speed, and that kind of stuff. So, but we're going to start with just elemental structure and damage, because elemental structure currently just determines its color. But the idea is that then we'll have also enemies of different types, and they'll have different resistances and so forth. So when it hits the enemy, then the attack gives that information. Then when the interaction happens, then we go send that to sort of like the attack or like damage handler, attack handler, whatever, which looks at like who got attacked, what do they get attacked with, does the math, how do like resistances or vulnerabilities affect the final outcome of the damage value, and then returns the damage value to whoever just got attacked. And then they can like remove it from their own health, and if it goes, and if they die, they die. And they deal with the death animation and removal from the scene. That is sort of how I thought about it. So the attack manager sort of builds the attack node, chooses its sprite, and ties into it the damage value and so on, and also then would have an ability to determine its speed and so forth. So that is the core idea. Because then, depending on that one, we can have all kinds of like, we have like a wave of like earth going forward, or like a firebolt that's actually thrown, and all kinds of like graphical things can happen because beneath the scene we just have no speed, damage, and choose graphics, that kind of stuff. And yeah, and it's a 2D game, so we don't really need to worry too much about the various directions it might or might not go. So what the projection does is essentially, it would call it has two outputs. One back to the circle itself, one to attack manager. Which is a global. And it creates the attack. So this way, the filtration node will have a sort of waste stat in here, separates the attack magic and the waste. Waste goes into the waste sort of just variable. Then it's sent here, and then using the non-waste magic, even if there's waste left in there, so we can use that for the whole logic there. So this one then determines the attack's elemental structure, damage value, speed, and so on. So we'll have different kinds of bolts, like faster bolts, slower bolts, waves, area effect, whatever. And this one then determines that one, like I said, yes, as damage values and so on, depending on the filter, and possibly other information as we progress here. Creates the attack manager, and then the waste, whatever's left over, is sent back to the circle to determine the cooldown. I know this is good, but the new thermal paste I applied quite literally suction cupped to the heatsink in my PC. Ooh, that sounds neat. How are you doing there, Margadilla 99? Other than having an exciting time with your suction cupped thermal paste. I haven't applied any thermal paste to my own drink. I probably should like clean it up and put in new stuff eventually. Old paste needed to go. It was chalk. Yeah, well, I mean, it is a very... It sounds neat. So the suction cup, so you like just had a really good applicator or something. Because I remember when it used to be like just paste. Freaking toothpaste. You just apply it there. Hey, I hope it works out. I should probably have a look at my own heating and cooling systems at some point and see what all needs to be fixed. Well, rig still works, and I'm afraid of, you know, if it ain't broke, don't touch it. Of course, it's Silver MX. Neat. I can't remember what I got on the CPU side. So we'll write attack manager, and we'll right here just waste. So if this would be the logic for this thing, then we'll look at, okay, what exactly does our spell state? So we do, we'll shorten that to SBSD so we don't have an SS here, because, you know, it's the internet, people could misconstrue. Well, we will misconstrue everything. So we will have in our spell state. And I need to wash my hands though. I look like I've been blasting the Tin Man with the Wizard of Oz. Ooh, that sounds... Hey there, Goko. Nice to hear from you again. Hope you're having a good time. Now our... let's do it that way. Now spell state will then need to have... what? Well, it needs to have current power. Actually, we would we have 3 separate forms of power? The spell state is listening to all of this here. Or 3 separate places for variables. I mean, we could, yeah. Keep on forgetting it. This ain't no IC10. We're not building integrated chips. We can have a little bit of a small bit of waste, I guess, in this way. So we would have a variable for the unfiltered, so that the circle can detect whether or not this is, you know, acceptable output and so on. Just because we also need to be able to detect what's happening here for when the player is building their circle. We can, you know, get instant feedback of would this actually work or not. You know, things turn red and whatnot. Because it'll suck if you build a thing and you think like, hey, this should work, right? Then you jump in the game and just, you know, things go poorly. Or maybe we will allow for that to happen. But either way, because we need an unfiltered one, so we'll know whether or not it can be used in the output. We can maybe eventually make an output version that can use unfiltered magic. Who knows? Maybe unfiltered is better for certain kinds of magic, like, you know, more like passive effects, like building a shield or whatever. Pure force. Then we have our variable for our filtered magic, and then a variable for the waste. Now all of these are holding a dictionary. Sorry. Which are the same one, essentially. We'll have like an elemental dictionary. We'll have a dictionary of all the elements and a total. So we'll have a dictionary. We'll have the total power of this magic, which would, for example, be 100, and then we'll have, you know, the elements, like, you know, fire, ice, etc. And in this example, of course, we have the 4 element structure, so the BF 25 and 25. So we can see a total just because, so we don't always have to calculate the total. It's just easy to have it there. Just snag it, and then we have all the values, and that is like in the unfiltered is 100. Then it goes through the filtering, and then it creates in the filtration rune, puts a null inside here, so we can then like check filtration is done. Cool, because then we just have an empty. There's nothing inside here, and then instead it has generated 2 copies of this one with the filtered output and everything else. So waste and a filtered. And in our original testing, our filtration will be 100% effective. Eventually, I think I want to have different kind of filters be differently efficient. We'll start with 100% efficiency, and then we'll tweak it to become a shittier one later. So these are the values that these two worry about the most. Wait, what else do we care about, really? Because this one takes this filtered information and generates the attack. So well, we'll put in one for at least a comment that we need like some kind of modifiers, because we might have like a filtration system that adds more speed to the eventual attack or size or so on. But right now, the minimum we need is just to make sure this thing kind of works. So we'll have an input that eventually, depending on what source is where, we get different kinds of attacks. So first we'll make filtration systems, and we can use the copy of the same one for all 4 of our first original elements. I'm hoping to eventually come up with a more complex elemental system than just the 4. I'm even thinking about doing something I read in a book long ago, where there was like the history of the elements in that like magical universe. How they also used to believe in like the four kind of 4 elemental structure, but eventually, similar to how the traditional physics changed yet remained the same after the discovery and study of quantum physics and so on. Then they discovered that actually there's even there's deeper underlying elemental structures that control everything, and they had so actually it turns out the fire and ice are actually the same magic, the magic of entropy, high or low, and so on. So we could then have I think that could be neat, having a sort of secret elemental system that would be then revealed to the player as they progress. So if you first start with a simplistic one, and then eventually you can start making it more complex, and when you realize, oh wait, these these interact and those don't, and these are actually secretly the same one, and so on and so forth, and it could be fun. But that is for a later point in time, not at this point. Right now, we just need to build the blocks and figure out how the logic flows from the beginning to the end point. Hello there, Mind Cozy. Hope you're doing well. Nice seeing you around. Sorry. Ooh, there we go. Okay, so. But the thing is, with this, we have figured out the spell state, the very core of it. Now, we have to look at the circle itself. My GDD is horrifying, but it works. It works for me. It works for the way I think, and this whole writing with your hands rather than just keyboard is surprisingly good for also for me to retain memory in my remember things and know what I've written, because you have overlaid memories. You have the memory of what you wanted to write and the act of writing. So now you have 2 memories of doing the same thing, and those strengthen the memories. That's why I recently read about that there's movement that they should be in schools go back to making everyone use pen and paper, because everyone's been using laptops for a while. And from my own experience in my own lifetime, I would say that's a very, very good idea. Because, like I said, you have the writing stuff down, just like reading stuff out loud will help you remember whatever you're doing better, because you have overlaid multiple memory forms of the same thing. Writing something down by hand is it's a physical action, so your body remembers that one. Then there's logic of what road drove you to do this and what you want to. Right. Rubber ducks, very important. Yes, rubber ducks are amazing. What's making? Well, Mind Cozy, we're working on a game. The working title, because I needed to call it something, is DIY Wizard, so do-it-yourself magic. The idea is to make a Survivors-like clone. Yesterday, how far we got was this simple. I made a little dude and everything. As usual, I got carried away with after I discovered how we can do polygons in this game. So see, you can see the aiming reticle is following the mouse. We click a button and we do a little attack. And not right now. When the attack hits an enemy, which is currently just that red square, If the enemy hits, we are registering the attack. The attack itself deletes itself. We shoot it out there. And if we open the remotes, we look at the level. We have our attack container. So we do an attack here. Whoops, sorry, there we go. And the container has a content for a little while. And after 3 seconds, it deletes itself. So it has a lifetime, speed. We don't have a size modifier yet, and we'll figure those out eventually, because I don't want to use everything in here to design everything I want. Because I think we can do some of these, like determining size and direction and so forth, a bit more efficiently than I'm doing it currently. But here we have, and of course, yeah, we can move around. Yeah. And yeah, I had a really fun time drawing this dude out of polygons. That is our original wizard. So now we're figuring out the logic behind this, where the idea is to have your top-down shooter. We're going to make it all look way better eventually. This is just for testing, so even the dude could have been a square. And I totally agree with that. More sense equals more memories. Yeah, more senses equals more memories. Exactly. Oh, nice. I need to learn more about Godot. Yeah, you can do all kinds of stuff. But yeah, it's a overlaying memories, because it's funny, because sometimes, like, when I read, well, back when, before more mobile banking became what it is today, we had our PIN codes inside this little, like, I had a little cardboard thing I carried with me with the numbers and PIN codes. For mobile banking, to log in, it asked me, give me the PIN code, this number. Then you looked at it, and then you had to write the PIN code. And the thing was, I noticed that if I looked at it quickly, I started like saying it out loud and closed it. Even though I can no longer see what I just read, I have no visual memory of what I just read, I could still recite the entire PIN code. Which also meant, okay, there's multiple senses and processes happening within me. Which, I mean, our conscious selves are a very small part of, our true sense of existence as the human animal. Our internal narrative is just that, a narrative. A way to comprehend and remember time. There we go. And that's also when I realized, like, okay, but then if you read something aloud, it helps you remember, because now you have a memory of both speaking it, hearing it, and the whole reading it part, comprehending it. Sorry. Some more warm drinks. I need to learn more about Godot. I like Godot. If you know Python or any Python-esque sort of advanced language, it's very simple. It is very Python-esque in its design, based on C++, I think this one? I can't remember. Also, it is very natural language adjacent. It's very easy, in my opinion, to get into Godot. And this one as well, we're using the sort of really super simplistic form of because when you start a game, you get to choose like in which what kind of complexity do you want to make it in? The most advanced one, where you can have the fanciest 3D graphics and whatnot. There's some like a mobile plus, where you can do like, okay, this can also work on mobiles and so on. And I'm using the most simplistic form when this should be able to work on like websites, mobiles, wherever. So that's what we're going with for now. It might be, once the project grows, we'll have to then sort of migrate it to a more complex version. But for now, I'm doing it just so simple. I can get it to work, maybe get it to itch.io, have people test it, play it. And the goal is to eventually turn this, I want to sell it for money. I'm hoping to get it on Steam. But if I can sell it for a little bit on itch.io, that'll be nice. And as we're done with this one, we'll start the next project. Yeah. And in case someone doesn't know what this got meant there with the rubber ducks, rubber ducking is a coding technique for problem solving. But the idea is you get yourself a rubber duck, then again you can have whatever it is. You can have, for example, what I have here is a small jar with amethyst. A keepsake from a tabletop RPG. And you take this object and you explain to this thing, which is classically is the rubber duck. You explain your problem step by step. And walking through the problem is the one that is a process that will also usually help you then figure out what the actual problem is and how to solve it. Because we are analog creatures. We're working on like digital problems, and our brain has, well, it's holding onto a lot of threads and predicting like insane amounts of information for about what's happening in the future and so on. It has to go like whoa. And that's an interactive game on Mayhem. Ooh, I got no idea what the heck Mayhem is, but it could. I mean, because this thing can run on HTML. This is the Godot mode in which I've done all my try jams, for example. So it works on HTML. I'm familiar with C++ and C#. Learning new terms / vocab is probably required, but the concepts are hopefully similar. Oh, absolutely. Your platform. Oh, right, that one. Wink-a-dink. Yes. That is true. I do have a Twitch interactive game idea that's been spinning in the back of my head as well. I was sort of 50-50. Should I do this one or that one? And I decided, we're going to do this one. And then we can eventually also start working on the Twitch interactive game idea that I've had. And we'll see if those work. But this one has been an old sticky idea in my brain for years. Now we're gonna goddamn make it work. Even if it turns out shitty, at least it'll be made. And I have noticed doing my try jamming thing is finishing a project, however shitty, is worth it. Because it's done. Because if you have a unfinished project and you think, oh man, it's so shitty, I'm not gonna finish this one, it will haunt you in a weird way because it feels like I never did this, it's not good enough, you're not really getting feedback, and then you sort of like dismiss it also on an emotional level. So I've noticed I don't learn as much from mistakes I made in projects I've abandoned, even though then projects I then decided to finish, however shitty they were, even if it is essentially the same mistake. It's weird. But we are weird animals. We are not logical animals. We are emotional animals, because that is what the brain is built for predicting the future, finding narratives, and existing in a very complex social hierarchy, especially where everyone is a kind of a psychic in the way that every human being predicts the future extremely efficiently. And the two brains theory. I don't know if that sounds familiar, but I can't remember what exactly that theory was. And was this phrase mean finished project? Well, ship it. Let's put it that way. Ship it. You can always return to it to do the next iteration, but ship it, however shitty. Because then also, you might get good feedback, like, hey, this actually was a good idea, and maybe next time try this and that. And they're like, oh, cool, nice. Because if you never ship it, no one sees it, and you think, what's the point? It's a shitty idea anyway. And then the depression hits, and then you just eat more and get fat like this. You become, the hot dog man. Part man, all hot dog. Now then, what was I doing? Oh, right, circle. So what is the logic of the circle itself then? Let's have a quick look at that previous layer. Now here we have the logic concept here of the circle, and it is sending the spell state into a rune container back, rune container back, rune container back. Okay, we finished this array. Calculate based on waste our cooldown, redo and then allow us to redo the thing. Every time the player launches an attack, we do this. We try to do the entire circle. The idea is, like I said, eventually add more complexity, maybe have like passive effects, like you can have a circle that also does attacks and functions as a shield, or then the player will have multiple circles and can have active at the same time. We'll figure it out when we get there. For now, just how do these circles even work? So we'll have a circle. We'll have the base class because we'll probably end up doing multiple different kinds of things here. So you know what, that reminded me of something. The whole, what does the main phrase mean? Finish the project, and well, just shipping it, because even shipping crap is better than shipping nothing. It reminds me of a very simple and interesting thing. I love it when people look at art or something and then think, I could have done that. My child could have done that or something. But the point is, you didn't. It's not a question of could you do it. Did you do it? That's the difference between, shipping the thing or not. That is why certain forms of art, however obtuse, hard to get into, weird to understand, it's just colored squares. What's the point of this? And it's like, well, That's kind of the point, is that there's no point, because it is referencing pre-existing art and styles which you might not have the reference to. So you think, like, I could have done that. Well, yeah, but this person did it in reference to these other history. You are not the intended audience, and that's why you don't maybe appreciate it. And that way, because not everyone has to appreciate what you make, be it art, software, gaming, whatever you do in life, Not everyone has to like it. Just, but someone will, hopefully. And as they say, the best design has a guaranteed audience of one, yourself. Because most likely, you are not that unique. No one is really. Whatever you really like, someone else out there likes too. So make something you would really like, not something you think other people might like. Because it's something you think someone else might like, but it's not really your thing, then you're not gonna get it. You don't understand why this thing is the best. What makes this thing good? Why this certain kind of weird art that you like, no one else seems to get. Why it's cool. But you do something you really enjoy, someone who enjoys the same things will eventually enjoy the same things as well. Because, you're making a product for everyone is a product for no one kind of thing. It's true. It's old. It's advice I've read from many sources, be it, writers, authors, artists, various designers. From a large part of history, from a large part of the world, it's a very common concept. Anyway, so the circle base, what do we need here? Well, the circle base class needs a name. So we'll do, again, same as the other one. We'll call this the circle name. Then we'll have a circle type. I don't know what all it could have, but it will eventually have circle types. Again, so that we can then identify the type and call upon the correct constructor. So first you'll read this information from a resource file, which has all these, all the info, including addresses for sprites. Speaking of, we'll have the circle sprite. Now, no matter what kind of circle we make, it will always have a size. And a circle rune array. Because for now, at least, we're putting them in an array unless we come up with a better way to do it. So this is the base class for circles. Most likely, this is the only thing we'll be using in the beginning. Until we then try to come up with more interesting ways. Or who knows, maybe this will never veer from this. So the circle needs name, type, sprite, size, array, eventually constructor, and then functions for I call it the walkthrough array. Walkthrough array, which is a function. Because the circle doesn't care what the runes do. And of course, for the ways, we have the calculate. The calculate cooldown. We can, because the calculate cooldown will always be the way it works, so we can use a must have a boolean for in cooldown, yes, no kind of thing. so no, can't be activated, and either it'll have its own timer. But if we're using this just as a class, so this is just a script, so we can't have a node. We could of course have a piece of code that would generate one, but I do believe we can just do an inline kind of timer funk here. So we'll do undo that one and just do here too, and a little arrow, and we'll do call temp timer question, or who should actually have the cooldown timer? So this, if the circle exists as a pure script, it becomes visual and so on only when we need it. Yeah, we'll have a circle UI that, based on the circle, will create the node for you, but I don't think it needs its own scene per se. Now, it only needs a script. It needs to know what it does and what it contains, do its own thing, but we don't need an entire scene. That'll just be like a UI which will be generated based on the circle and its in question and its contents. So maybe the timer should be in fact handled by the player. But the thing was, because I was hoping to use this same system also for the enemies. So any attack you see in the game is also something you, the player, can make using the correct kind of magic circle thing. And we'll see if we can do that. Because I was thinking it could be fun to have like procedurally generated enemies, and that way, depending on the procedurally generated like elemental constitution. So we'll have like, say, we'd make like some generic slimes, you know, in many games. And depending on what kind of map there, or which area of the map is generated in, because I also want to then figure out how to procedurally generate terrain. Then depending on where it's, you know, born, is like the map has a little like lava area, has some fire magic there, so there's more like fiery magic slimes there. But the placement would also have some like earth magic, so there'd be fire earth combination and you know in various ratios. And that way we have like generic elementally flexible enemy type, which then, you know, gets its color, because, you know, color is a very good visual indicator to the player of what's going on here. It determines its type, and its type then determines what kind of attack it does. Hey there, Benji. Hope you're doing well. Good morning. It's going pretty well actually so far. We've spent the past hour getting sidetracked and also just walking through the logic of how exactly we would build the magic circle for my magic circle based circle murder game. Because yesterday we built just a visual testing platform essentially, and now we need to figure out how do we then continue the testing. So now I'm like just rubber ducking with everyone here, talking through how the logic would work. And right now I'm thinking, so if I want the base class for the magic circle where we place our runes to make our attacks, so it has a timer for the cooldown. Now the timers in game usually are nodes inside Godot. There you can call one through through code, which specifically is mentioned as a sort of temporary one. So like for example, we go here to script. I'll look at the vector 2. That's not what I want. We go here. Create timer. Scene tree, create timer, bool time, float, blah, 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 blah. Returns a new scene tree, try timer. After seconds have passed, the timer will emit scene tree timer timeout and will be automatically freed. So we can use a get tree, create timer, timeout, then print end. And that's why I'm wondering, like, either we do a temporary timer like this through code, which is then would be very handy, or we have an ongoing timer for the player, which would also be handy because then the player could have a UI element where we can see whether or not your attack is in cooldown, because we keep on like generating this in the circle. we'd have to link a graphical representation with our temporary timer every time we create it, which isn't necessarily bad per se, but if we instead we had a, like, the player global or the player scene, it would contain the timer, and the code for the circle is just telling that one what its new value is, and then it'll do is count. It'll count all the way down, give it a timeout signal, which would then inform whether or not the circle can be activated again. The circle could be listening to the signal, because Godot has signals, which are handy because you can then like have various things like linked to each other through the code, and you just have like, okay, when you're done, emit signal like this one, timeout. And when you have some other function in another scene, when they enter the same scene, you'll have to link them so they can actually hear each other. But you don't have to worry about what this thing does anymore, because you know it's giving out this timeout signal. So when the second one detects this timeout signal, it does a thing, and so forth. So you can have, they're kind of neat. I haven't really used them that much, other than the clear inbuilt ones you do from here. But we could see about playing around with that one. Now, Mind Cozy is saying, I remember making a game when I was much, much younger. Not just telling people that attacks went through walls, because solving that problem was beyond my ability. Yeah. Well, the handy thing is, using Godot, so it solved that for me. We'll just make walls solid objects and make our attack detect. If you're hitting an object, detect what kind of object is it, which is what we're doing here, for example. And on body entered. Then there we get a node 2, and it goes into body. This is a signal thing here. You see, jump here, we do signals. So inbuilt one for these nodes, we can quickly double click here for like, oh, the animated sprite detects if an animation has been changed, and so forth. Frame has been changed, sprite frames changed, so on. Because we're looking at that one, not this one. There's a similar one for this one because it has a physics body. So our attack is actually just an area that is detecting things, and I'm using the signal that detects if a node that is that the engine would qualify as body goes in here, and we check if body is in group enemy. If yes, print enemy hit and queue free. So delete yourself. It just mirrors that music again very loud. There we go. Listen, I got old chili willy chilla hop. And how we're doing this one is because next to signals we have groups, and inside the enemy cube we created a group for it, and we call it enemy. And that is how enemies do literally fuck all currently, like nothing. It exists. The attack is itself an area 2D, so it's just a detection area, which you could use to detect, if player goes inside this area, I don't know, open door, turn on light, that kind of stuff. For us, we're using that one because we don't need physics for this attack. It just detects if it hits an enemy. If yes, delete yourself and give it the attack information. Now yes, layers and physics bodies are such a simplification. Yes, they're very nice, aren't they? Because otherwise you could do very complex math to make things be like pixel perfect. Do they interact with each other or not? Or then you have certain areas, like for example, you could use a radius for a circle, but if you're doing very simple math, I wouldn't, because that is actually has an unnecessary large amount of steps. But if you make a grid if you're doing a 2D, I think even a 3D one, just reading the X, Y, Z axes from a point, they're going to have a detection area that way. And because it's essentially how I used when I did a ray tracer long ago. I did the more complex math first, and then later on I realized, that's why people use vectors, for like triangles and shit, because the math is so much simpler and you can just do it like so many times. I'm literally melee killing enemies through walls in The Last Caretaker right now. Nice. Love it. Yeah, so it's fun, attacking through walls is, it's an old problem, but it still exists. Because most likely, yes, the walls are detecting the physics of the player character, so the player character can't get through the wall, and the attack would then be generated in front of the player character, which might then be generated on the other side of the wall. And, in between those phases, the attack can't detect the wall because the attack doesn't move forward. It is generated into existence an X amount of distance from the player. So if there's a wall in between, they never saw each other and the attack happened here, kind of thing. That is what I'm assuming is happening. Now then, back to this thing. So we have an in cooldown temp timer. So I'm thinking that we could, use a temp timer, or we have it just sends that information to the player. The problem was that if I want to use the same logic for like all kinds of magic circles in the game, then the cooldown can't be just on the player. The enemies need to have the same one. They might have their own like secret modifiers where, because it's a fire, like super fire aligned magical entity, its cooldown on fire-based attacks is actually much slower than faster than for players, because the players just would be human, I guess. That way, then the cooldown would be handled by the entity that possesses the circle. So you would be... Shit, how did that work? Giving it the player is easy enough. Because then we just have a player global handles these things, and it just informs the player global, like, hey yo, you're on cooldown now. Cooldown activates a ball, like inside the player global, then turns into an on, like, yep, in cooldown. You try to do an attack, it checks on the global, can we do an attack? Says nope, no you can't. Cooldown's over, ball flips, now we can do an attack, whoop, and then it goes through the process again. That'll be one way of doing it. But if you want enemies to do the same thing, now of course, we could just have essentially do the same thing happening within a scene. I'm just seeing if I can figure out a way to be in a way that feels elegant in my head. I don't know if it is actually an elegant solution, but because I'm a moron. But hey, that's why I'm here, learning, doing the things, trying to get better. But I don't want the circle actually to give a shit about its own cooldown in that way, so it doesn't handle it. Whoever owns the circle handles the cooldown. That way the circle doesn't need any node structure, it actually need to remain as a pure script file. But we could have the temp timer in here, but then again, like I said, because I want them to be able to animate some sort of cooldown system in-game. And for that, it'll be better if the cooldown is actually calculated elsewhere. But how do they link to each other? Does it just say... Ah! You see, when we activate a circle, it calls a function. Activate circle. We'll just do it like this. We'll just activate it for this one. Calling our function of activate, which has a return value of input of something, I don't know. And a return value of the cooldown. And this function calls upon walkthrough array. Just got walk there. And then we loop and we do everything that needs to be done. Once everything is done that we need to do, the attack is generated and so forth. That is when we're done with this function. And then it simply returns cooldown. There we go. Nice and simple solution. Because then whoever activated it will get the cooldown value back, and based on that value, they'll mark themselves as, you know what, we're on cooldown. Or more likely, we'll have them mark themselves first on cooldown, then activate this thing. Just so that, you know, we don't get like some sort of weird mega spammy thing. And then it gets its return value for the cooldown, activates the timer for the cooldown, and once that one's done, it marks itself as, okay, we're off cooldown. Now you can activate the circle once more. So the circle doesn't give a flying fuck about a in cooldown state. So we do this. So we just have to make sure that everyone and anything that has a magic circle will in fact be the one dealing with the cooldowns. This way it could be interesting, because we could build like, I don't know, some structures that have like a magic circle kind of thing. The player might find them, and then depending on how good you are at reading the circles, you might have to be facing a puzzle like, oh, how do I deactivate this shield? And okay, what if I overpower this thing? Then this will, you know, will lead to that, and so on, and that way we'll be breaking the shit. You see, that could work. So now we have the core idea here for a base class for the circle. This will be a pure script. You have the logic for the circle and how it's walked through the array handles the runes. Got to figure out what the different runes would do. And we'll have a spell state variable here as well. Which we might also try to, I don't know, maybe it'll be easier. We also do the spell state as a structure, predefined one, so we can just always like create new spell states, and then it fills it out, and once it's done everything, we delete the spell state. Maybe. That is for when we get to the point where we figure out how to do that. I pushed the wrong button. The hands are stuck, not that thing. Yeah, and that problem gets even more complex in 3D games if your attack is a function of the volume of your melee weapon and doesn't just hit where the cursor is aimed. You always amuse me. Yeah. For 3D games, especially like FPS ones, it's funny because there's so much happening in the screen that tells you as a player, like, oh, my actual weapon is going there, when in reality it's just like, are these two areas overlapping? Yes, no. If they are, attack worked. If they didn't do anything. Otherwise, it's just an animation. And granted, that's a complex problem to solve. Yeah, it would be, but then, of course, the more complex you make your problem to solve, the more math it takes. So if you want your game to be like nice and fast and smooth, you gotta hide the fact that the reality of the situation is far simpler than it actually is. Kind of thing. So, now if we jump. First, we save our changes here. So I think we've gotten some good work done today. Now, if we look at our... There we go. Did we have the... Here's the circle base. That I started... Class name, circle base, extends node. As far as I know, it kind of needs to... Smoke and mirrors, as it were. Absolutely. I mean, I feel like that can be solved with a simple raycast. For example, it's making a hit sound and a particle effect on the wall, but still killing the enemy on the other side. Yeah. Smoke and move, yeah. But I think the internal game logic of enemies and animation might be then handled by separate parts, which is why the logic of our attack, does he hit or not, goes through its full thing, whereas the animation detects interaction and then does the swoosh, the particle effect and whatnot, is what I'm assuming. Because many games like in 3D stuff, I'm assuming at least, because it's easy to then use, range or area. So there's a volume for your attack, and that one can be larger than the thickness of the wall, which leads to the attack, even if it would stop at the wall with a raycast, would still go through that one, unless you want to add more detection, which would be a large amount of raycast for making sure that your sphere would be cut off where the actual wall is. Your sphere of effect for the attack, and that would be a lot of comparisons for a lot of points. So it's easy to just let the AoE be there and make thicker walls. Would be one solution. Here we go. Activate circle for current rune in rune container. Current rune that do the thing. That's your freaking circle name, type, sprite, size, array. Whoop. We have circle. Circle needs to have the container for runes and be able to progress through them in order. Yeah, that is a core concept here. Circle size and rune containers. Yeah. And rune containers would be an array of runes. Like I would like to write here, just runes, but I can't do it right now. Oh, I can do rune base though. So there, that works. It's an array and it has to be a rune base. Oh, wait, no. Other way around. We do an empty array, but you're an array of type rune base, if I remember correctly. I like strict casting. Because my first language was C, so I'm used to casting things, and also because I use whenever I use these more abstract Python-esque things, I just feel so unsafe if I can put like whatever in a variable. Because I remember using the fact that I'm so used to the fact of getting error messages if something that does not belong in a variable is tried to you try to put it in there. So I can, like, if I'm not getting that error message, I can trust that it'll work from here on out. I know what the output will be and the input and so on. Because otherwise the entire thing breaks. Alright. I'll put this one down. Give me a quick sec. There we go. There we go. Okay, so we'll have our first variable, which would be the not a hashtag here, which was the circle name of type string equals default circle. Then we have a variable for circle type, which I want to be an enum, but we're going to put in just an int here, and your default is 0. I'm going to open this thing and move it to a different screen so I can see all of that. And then we'll just hope the game doesn't crash while we do this, because I can't see OBS. Oh yeah, so then we had var circle sprite will be a string, empty, add a comment, address to circle sprite. Then we had circle size, which we have there. Now then we have the circle rune array, which here we're calling rune containers. We'll use circle waste, cooldown, use hashtag big to do makes it all yellow, and delete question mark. We do func constructors class hashtag. So into comment to do constructors for different circle types. Hey there, Doom Rats. Hope you're doing well. And no, thank you. Oh, shout my name out like that. And we'll have the walkthrough array, which activate circle would exactly do. So we'd have. Hope you're doing well, Doom Rats. What are we calling this thing? It's annoying me that I want these things to be, so we do a process runes. Handle runes, freaking. Handle runes. And then a func for calculate cooldown. Yeah, although you would have a return of a float. Do we get any? Yeah. Return. Just, no, nothing for now. Spell states. Variable, yeah, we need one of those. Hashtag to do. Spell states its own time, question mark. For spell state, which would currently be a dictionary, which simply starts out as be empty. So Sunday, what's happening here? Well, hello, Doomrat. Yes, I was on Monday, yesterday, I started my new long-term game project finally. So we're doing a couple of hours at least, a minimum of 2 hours for the foreseeable future of every day. We're going to start with doing the game dev on this, my current long-term game project of trying to make a Vampire Survivors-like Mega Monkey game where the central mechanic is based on the idea of building your own attack as a wizard using a sort of a spell circle and magical runes. Because it's an idea that's been stuck in my head for a long time, and I've been meaning to start a long-term project for ages, so just do it. Had to start. Func activate cooldown, walk through, return cooldown, there we go. Now you will then also, in fact, return float. So you do current rune, do the thing, in the end you return, calculate cooldown. So this is the base concept for the circle, because now we could do just circle, new circle base, or bar something that's equals circle base dot new. Now we're gonna have to then make the actual constructor so that the new would construct them in different ways, or we do a new and then we call it a constructor where we give it the resource file where we store all the information, including the addresses for stuff, and it will then determine what kind of circle we have just now created. And that way we don't need to have these in existence for every single possible shape of it, but always call one when we need and create one from the resource files that are saved in the engine itself. Because the Godot has its own resource file logic. So rather than using it like an external XML kind of thing, using the resource files that Godot uses is usually the best way to go, as far as I've understood, because they've been designed to be, they've been optimized to work with Godot as efficiently as possible. So that would be the most efficient way. That's why we're gonna be using those when we get there. So here we have, and I like the fact that if you do a all caps to do, it turns slightly yellow, so it's even visually slightly easier to see, like, what the frick is going on here. Now, for the to do here for the activate circle is, do the thing, and we give it spell underscore state. And that's why I wanted to have a separate pre-made type. It feels a little weird to make an entire class for it. Or maybe that is what we want to do. But I feel like there was a similar way to do these by using the resources. I'll get there. We'll get there when we get there. But I guess we could here just write our basic spell state here. The spell state will actually contain further dictionaries. Now, let's see. If I enter, we can do it like this. Excellent. So the very first thing it would contain would be the just called the unfiltered power, which in our, I'm writing shit down here. Then we have the filtered power. And then we have the waste power. There we go. Here we have, circle waste. Excellent. All right. Expected. What do you do, my friend? Oh. That was a comma. There we go. Fixed. Now then we'll have, each of those would then contain our list of how we end up defining how elements work in this game. I'm gonna do a little bit of a bring you back so I can do this and then jump here. So now you can see OBS again. I'm a little awkward always when I can't see OBS. Because it's happened a few times. Game's going fine. Suddenly, I don't know, internet decides like, you know what? No. God damn you, ISPs. I'm gonna see if I can do so resource is actually a class. Base class for serializable objects, which is what we want because we want them to be serialized. Description: resources are the base class for Godot, all Godot specific resource types. Serving primarily as data containers, so they inherit from ref counted. These are reference counted and feed when no longer in use. Having been nested within other resources and saved on disk. Fact scene, one of the most common objects in a Godot project, is also a resource, uniquely capable of storing and instantiating the nodes it contains as many times as desired. Huh. Anyway, DD script, resource can be loaded from disk. of the resource path using GT script load or preload. The engine keeps a global cache of all loaded resources, referenced by path, and the resource will be cached when loaded for the first time and removed from cache once all references are released. When a resource is cached, subsequent loads using its path will return the cached reference. Note, in C#, resources will not be freed instantly after they're no longer in use. Instead, garbage collection will run periodically and will free resources that are no longer in use. This means that unused resources will remain in the memory for a while before being removed. Online tutorials, resources, and when and how to avoid using nodes for everything. Yes, which is exactly what we try to make sure here we don't do. Nodes are the only things we see on screen. The actual scenes, the actual enemies, the players, and so on. And then the attacks and so forth. Which is why we want this all to be functioning in resource, in script form as far as possible. And we only sort of create the scene, the thing the player can see if necessary. Because, well, all of that takes memory. I'll click on you. I'll open up this one. Yeah, it's getting a warning. I'm getting old versions of the freaking resource of the tutorials. I'm like, yes, I know. Because I'm on 4.3 stable. Because I haven't updated my Godot in effectively years now. There we go. So, creating your own resources. Like any object in Godot, users can also script resources, and resource scripts inherit the ability to freely translate between object properties and serialized text or binary data. T-res or res or res. Okay. They also inherit the reference counting memory management from a ref counted type. This comes with many distinct advantages over alternative data structures, such as JSON, CSV, or custom TXT files, and users can only import these assets as a dictionary, or as file access to parse. Since resources to parse is their inheritance of object, ref counted, and resource features. I can define constants, so constants from other data fields or objects are not needed. You can define methods, including setter getter methods for properties, of abstraction and encapsulation of the underlying data. If the resource script's structure needs to change, the game using the resource need not also change. Yeah. That is exactly what I'm going for here. They define signals, so resources can trigger responses to change in the data they manage. And they have defined properties, so using them 100% that their data will exist. Now the auto-serialization and deserialization is a built-in Godot engine feature. Users do not need to implement custom logic to import/export a resource file's data. Makes sense, yeah, so then I don't need to worry about how the friggity Frackman does that properly. I'm just like, yeah, Godot, you deal with it. And users can even serialize sub-resources recursively, meaning users can design even more sophisticated data structures. And users can save resources as version control friendly text files, T-res upon exporting a game, and Godot serializes resource like files like binary files, res for an increased speed and compression. Version control, right? Yeah, I need to make a GitHub for Son of Hanno as well for this project. I have a personal GitHub and it's not doing too hot. I haven't done anything in years. And they can extend other resource types besides just the base resource. It makes it easier to create custom resources in the inspector. Yeah, and that is also very handy. When editing using the visual inspector, the editor to do stuff. So set the script property in the inspector to be your script. That makes it easy to create custom resources in the inspector. Create the plain resource object in the inspector. This can be the type that derives resource, as long as your script is extending that type. The inspector will now display your resource script's custom properties. If one edits those values and saves the resource, the inspector serializes the custom properties too. Add save resource from the inspector. Click the inspector tools menu. Top right and select save or save as. If the script's language supports script classes, blah blah blah, and then streamlines the process. Anyway, quick look at that one. Defining a name for your script alone will add it to the inspector's creation dialog. This will also add your script to the resource object you create. Let's see some example. Create a resource and name it botstats. It should appear in your file tab with the full name botstats.trez. Without a script, it's useless. So let's add some data and logic. Attach a script to it named botstats.gd. Now just create a new script and drag it to it. If you're using C#, you need to annotate your resource class with the global class attribute for it to show up in the create resource GUI. Extends resource. Export var health sub-resource strings. Make sure the other parameter has a default value, otherwise every parameter has a default value. Otherwise there will be problems with creating and editing your resources via the inspector. Init p health p sub-resource and p strings. Now create character body 3D, name it bot, and add the following script to it. Ready? Uses an implicit duck type interface for any health compatible resources. If stats.health equals 10. Print stats health prints 10. Stats is the resource. Now select character 3D in the node we named bots and drag and drop the bot stats. Trace resource in the inspector it should be 10. Obviously, this setup can be used for more advanced features than this, but as long as you really understand how it all works, you should be able to figure it out. Everything else related to the resource. Okay, wonderful. So it's not the resource per se that exactly we want. But yeah, so we're going to change the extends from node to resource. We can use a class name to just, have a class structure. Register name classes. You can give your class a name to register it as a new type in Godot's editor. For that, use the class name keyword. You can optionally use the @icon annotation with a path to an image to use it as an icon. Your class will then appear with this new icon in the editor. Neat. Icon res interface icons item.png class name item extends nude. Oh, cool. Like that. That can be pretty handy actually when building these things. Tip: SVG images that are used as custom node icons should have the editor scale with editor scale and editor convert icons with editor theme import options enabled. This allows icons to follow the editor scale and theming. Settings if the icons are designed blah 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 blah. I don't give a shit. Here's a class file example. Save class character. Var health func print health print health. If you want to use extends too, you can keep both on the same line. Class name my node extends node. Inheritance: a class stored as a file can inherit from a global class, another class file, and an inner class inside another class file. Multiple inheritance is not allowed. Inheritance uses the extends keyword. Extend some class. Extend some file to GD. Inherit extends named class file. Inner class in another file. Cool. Cache. Enemy class. Enemy. Preload enemy GD. Now use is to check inheritance. If entity is enemy, entity.apply damage. Okay. So currently we're using the if is in group enemy to detect whether or not we should do something. So we made an enemy class. Could I then do it like if body is enemy? I don't think it'll change much, but could be neat. Then it's not based on the node directly, but the script. Would this be more efficient? Meh. We'll find out eventually. To call a function a superclass, i.e. one extended in your current class, use the super keyword. Okay, right. So super is, if we extend a node, then we use super to one extended in your current class. The super keyword, yeah. Yeah, func, sum func, x, super x. Yes, this calls it from the parent. Okay, yeah. Especially useful for the functions in extending classes replace functions with the same name in their superclasses. If you still want to call them, you can use super. Ah, wonderful. Cool. If you need to call a different function from the superclass, you can specify the function name with the attribute operator. Overriding return 0. This overrides the method in the base class. Don't override. Return super overriding. This calls the method as defined in the base class. That's pretty handy. The class constructor called on class instantiation is called _init. Init, yeah. And if you want to call the base class constructor, you can also use super. Syntax. I know that every class has an implicit constructor that is always called, defining the default values of the class variables. Super is called to it's called explicit constructor. So func, init, arg, super, some default are called the custom base constructor. Finding the default values. Right. Note that every class has an implicit constructor that is always called. Find the default values of class variables. Let's explain through examples. Consider this scenario. Variable entity null, message null, func init e equals null, entity equals e, func enter m, message equals m. Idle GD, inheriting class. Extend state GD, inherited class. Func init e null m null, super e, do something with e. So he does that one. And message equals m, that happens to, even though we don't call that one, we do call that one. If the inherited class stateGD defines an init constructor that takes argument e in this case, then the inheriting class idlegd must define init as well and pass appropriate parameters in it from stategd. idlegd can have a different number of arguments in the base stategd. The example above, e passed to the stategd constructor is the same e passed to the idlegd. Okay. And if idlegd's init constructor takes 0 arguments, it still needs to pass some value to the stategd base class, and it does nothing. This brings us to the fact that you can pass expressions to the base constructor as well, not just variables. Huh. Are you going 2D or 3D with this? I'm doing 2D. Or 2.5, we'll see when we get there, but we're just to keep things simple enough, we're going just top down 2D shenanigans. Well, a static constructor is a static function, static init, that is called automatically. The class is loaded after the static variables have been initialized. Static var, my static var, static func, static init, static var equals 2. A static constructor cannot take arguments and must not return any value. So can I use a static init? No. Class file contains inner classes. Inner classes are defined using the class keyword. For instance, using the class name.new function. Inside a class file, we have an inner class in this class file class, some inner class var a 5 func var func init var c equals some inner class.new. So this is what we want for the magic consistency thing. At least possibly. Classes stored as files are treated as GD scripts. They must be loaded from disk to access them in other classes. It's done using either the load or preload functions. See below. Instancing of a loaded class. Resource is done by calling the new function of the class object. Variable my class, load my class GD. Load the class resource when calling load. And preload the class only once at compile time. My class preload. Walk init variable a dot my class new dot new and a dot some function. So my sort of issue here is these would be dictionaries, so I could have a dictionary of dictionaries for the spell state. But I'm wondering if I should make the spell state like its own class. So we do class the spell state class. Okay. Now we're ready to go. There. Init classes. Class, some init class, var A. There we go. Var unfiltered power dictionary what a silly goose. So then we'd have these, and these would all have no. You see, that wouldn't work either. What I would want is the variable of just call it power. And it would be a dictionary. And here we would have, total fire, air, earth. Kind of. Essentially like that. Well, like I said, I was hoping to then be able to, if necessary, expand on that whole logic. The powers combined, we summon Captain Planet. It's true. He's very sick. He's full of microplastics nowadays. It's very tragic. He's had better days. Alright. And this would be like a power class. So when it's created, you'd all have these. I don't think Captain Planet when people talk about elements. It makes sense. And welcome in, Raiders. How y'all doing? Welcome in there, Mercenary Mage. What are you up to? Ooh, also doing some game dev stuff. Hello. Can't stay to chat, but have a great stream. Hey, thank you for the raid, Mercenary Mage. I do appreciate it. And I hope you had a good stream. And I hope you have a wonderful day, whatever you get up to. And Captain Microplastics is less powerful, but still impressive. That's for true, man, Cozy. He can still, annihilate everyone and everything. And welcome in, Raiders. I'm Hannu, son of Hannu. Variety streamer and occasionally, like this, an extremely amateur game developer trying to finally starts and work on a long-term project. I've been doing a weekly game jam for the past almost full year. That happens every weekend. The Try Jam, we have 3 hours to make a game. And now this week, we finally started working on our first long-term project, because I feel like I've gotten the handle on a lot of design stuff here. I dropped off the kids and ran off. Typical. Well, doing right. That's what I do too, because usually by the time I end stream, I have to go and walk the dogs. So it's also like, hey, gotta run before the dogs poop on the floor. These magic users always do this. Hey, we're building a magic user game right now, the DIY wizard. Don't talk too much shit about mages and wizards. Now, this is the thing I'm wondering, should I make just a... Because we can define our setters and getters for all the elemental systems. We can have an inbuilt... functions for determining those. So this way we can have the power class new. This is just a class. All it does is contain this one thing. But I want to be able to just pop out an empty one whenever. Of course, I could just make a function like, hey, yo, return a dictionary. Give me a fresh one. And that's what I'm wondering. Should I have? What all do I do with these power classes? The point is, they start out empty. Then we get the unfiltered power from the power source. Then we send the spell state over to the filter, which essentially deletes the unfiltered power and then does a new copy inside filtered power and waste power. Then we go to the projection rune, which looks at the filtered power and deletes that one. Cast a spell, and then it returns in its final form the spell state with only waste power inside left, and using the total value inside that one, we calculate the cooldown and send that back to whoever activated the circle. Yeah, the game will work. Then, the game we're going to be playing later will be Stationeers, which is mentioned in the title. And currently, we're working on our DIY wizard named game, where it's just we're going for just a survivors-like bait game to essentially be the base to experiment on building a crafting system for making your own attacks, which is building a runic circle, a magical circle of runes, where we have power sources, filters, multipliers, whatnots, and then a projection type rune that determines. Oh, sorry about that. Hiccups. Determines if you're making a bolt or a beam, will there be an explosion, and so on and so forth. But yeah, but we started yesterday, and so I'm just still trying to figure out just the base classes, how the whole class system all works here, so on. Here, we're extending node into the circle base, but I don't think we need. This shouldn't be a node because we're not doing any of that. So if at best it'll be a resource, or it won't even be that. Because I'm thinking if we use the resource here logic to hold power classes. Because so far, the problem is no one else uses power classes. By making it an inner class would make things easier in that So then we can use the new function. Like if we look at the tutorial we were looking at here, some inner class where a func print value of a print a func init or c equals some inner class dot new and c dot print value of a. So into variable c we put this some inner class dot new, and on that one we call that function print out of 5. And we need to define these inits as constructors. But that'll probably be easier. Because I don't know if your circle base will need its own init. Oh, wrong one. Yeah. But where would we store such a thing? It's good old generic resources folder for now. And yeah, we need to remove some waste because that thing is always it's taking surprisingly long to do all that. Now set resources, we would do then a create new script, and it'll be elemental power class. Great. Right, open that one up. And resource for now, I guess. Oh, this is this one. Don't like this one. Tickles my brain in an uncomfortable way. So now it's an elemental power resource, which means you go away. I believe we do that. So we either have a dictionary or some internal functions that, deal with all of these. Setters, getters, fire, air, earth, total. So we'd have like var total power is a float, and equals 0. Then of our air, fire, air, water, earth. Fire, water, air, earth. There we go. And then we can define specific setters and getters here. We can also have good old func of calculate total where total pot power gets the value of just fire plus water, air, earth. That'd be one way of doing it. Yeah, so we're gonna end up with a whole lot of this nonsense, which most likely will be virtually removed eventually. Right now, though, shit kinda works. Now, the resource would be handy because yeah, it does the auto serializations, and we don't. And if the thing doesn't exist, it'll automatically delete itself. So yeah, that'll be handy. Circle base. There we go. Elemental power resource, new. And generated there. Except, of course, they shouldn't. What these should have here at this point will in fact be just null. Because it starts out empty. And this way, when we go into the first power source, it creates the elemental power class inside our spell state dictionary and puts it inside the unfiltered power. Spell state is returned in its edited state into the circle, and then it goes to the next rune. Sends the spell state to that one, which would be a filter, which then would in its code remove it takes unfiltered power, and from that generates filtered power and waste power, deletes that one, returns it here. Then we go to the final rune, which is the projection, which would then use the filtered power to create the attack, and deletes that one when it does that. Returns it here one more time, and we all we have left is the waste power, and from there we calculate cooldown. Spell states. That's a dictionary currently. And that way we and returns that as a float pretty much to the one who activated the circle. We use that float to determine the cooldown or when they can next time attack. Right. I think we're getting there. Yeah, it's better that way than having it here because, yeah, it's the individual runes I'll be calling and dealing with these bastards. These thingamabobs. And that way, we can change these things. We could even change this from a dictionary because we know that it currently only has these three values. this could be an array of undetermined length. You see, then we just add in the new power class pretty much into the array. We get it from the power source. We send it to the filter one, which takes that single one. Oops. Grabs it, creates the two new ones, deletes the old one. Then we get from an array of 1. Then we have an array of 2. And then we use those two to create the attack. Then we're back to an array of 1. Use that for the cooldown. And then it has been emptied, the spell state array. That might make more sense. Because it's not used anywhere else. It's pretty much just a container for the elemental information currently, and possibly more modifiers in the future. And if we're using this in an array to carry this information back and forth, we can use relatively simple logic to deal with this. And we can add possible modifier spots in the elemental power resource. So now the rune circle doesn't need to know or care, because I want it to care as little as possible about what's going on. It just manages the runes and the power flowing in between them, and or the input itself, and so on. So this is everything this thing should be doing. So we'll have a var spell underscore state is an array of elemental power resource, and we come into existence. I want you to be empty. That way, Opa. Then you get the array, and it should only have the waste information. Or it doesn't even need to be an array. You see, we add to the elemental power here. We have a total power. And we also have waste. Power type float equals 0.0. And these in themselves could also be then stored in an array. Everything happens in an order. And then this one could contain both the unfiltered, and then after filtering, it turns into, we have the filtered, and the waste. So this one is built to just be the data structure for carrying that information of, well, the amount of power we got. It starts at 0, then it gets fueled up by a power source. Yeah. Then the filtration does some editing on this thing, and we would then have possibly, like I said, we had two places. Like, do I care about the waste powers, elemental state? Yes, we do, because we might be building a system that would eventually have two filters. So first you go through one filter to grab all the, say, the fire magic from it and send it to point A, and then it creates from the waste, grabs even more, like grabbing also all the water magic from this one, send it to node B, and then in the end we're still left with some waste to determine our cooldown. Yeah. So then we will be eventually having multiple power resources. Okay, so then my first idea of just having a single one go through it all won't work. So the waste logic needs to go. We'll just hash it down for now. And then the circle base An array would work. The dictionary could work. Needs more thinking. Needs more experimenting. And right now, what I need is a quick break to the toilet. So, put up the BRB. And most likely it will be gone for 2 hours. And I think if I keep on going, I could be going on for hours with this one. But I don't think we'll be doing that on stream. We'll be jumping into Stationeers shortly. But for now, yes, I'm going to have that little break. I'll see you soon. Hello. I have returned. I've even refilled my drink while I was out there. So, a couple of hours, not that much deving, but a lot of drawing and thinking. And I've said it before, but I do like doing this stuff on stream. I think it's valuable. And I hope it's valuable, at least. Let's put it that way. For anyone who ever comes to watch this and sees this and gets to follow the sort of like thought patterns that led to the solution, rather than reading a guide with a finished solution, if you will. So I've always found that I always found it like interesting and valuable myself. There we go. When we can see, someone can explain like, well, where's the thought process that led here? How many mistakes were made before you found the correct solution, and so forth. Close Godot in the background. Took a little while, but I got it done. Make sure our mess of a game design document continues to exist. And we open up Steam, and we hope there aren't any major updates to Stationeers happening right now. And then we have a look-see at changing that category. Jumping to Stationeers. So you can hang on to that title. Wonderful. Now available. Just released from early access. Terra Invicta. Oh, that's why Walls was playing it now. Seemed neat, that Terra Invicta. There we go. Click that button. Scroll down here and have a look-see at our game capture options. Try it again. There we go. Rocket Station. Dance. Also, while that loads, do a little bit of reorganizing my windows. There you go. Got my lurks on, apparently. Ooh. Easier too. Here you go. Lurks everywhere. Getting all this shit working in the background. Most importantly, we pause that one and jump into the... Oh, wrong one. Where the heck is... There it is. There, you hear it. Got the music on and everything. Oh, yeah. Okay, so caves are possible. We have a large hole into the ground. I think our small autominer needs one more movement for the final big hole. I still don't know what exactly I'm going to do with the hole, but now we got one. Yeah, the space beneath the base is going to be the general processing area with the centrifuges. We currently only have our 6. What is a deep miner can be used to harvest and steady flow of resources. And a rocket manufacturer can stuff. We are hungry. We are thirsty. Oh, right. I was supposed to deal with this, like, off stream, but I didn't. Well, let's run this way and hope for the best.
Teammate for stations.
Teammate for station is very true. Hey there, Napzor. Hope you're doing well. Knappity knap. Knippity knop. Now we're very hungry and very thirsty little stationeer dwarf, space dwarf running along here. Now, we also need to then run into the other end and check on the ogre. Because I just sent it there without a proper shoot connection because I couldn't be bothered. Ran out of shoots if I remember correctly. Yep. Oh, we had a trader. Did you have anything neat? Oh, right, you had these frames and things. Okay, we'll have a look at that later, once we know what we are or are not building. And eventually we'll see if that works. Do I have food on me, by the way? Yeah. Salad. True. And we get naked in the greenhouse. This one does. Bread. Loaf. I hope you're doing well, Knapzor. Hope you have a pleasant end of morning. Man, bread is magic. And also, apparently, so are drinking fountains. And collecting, you know, when you collect the plant, you have to go through the, like, the, you know, there's the bar. But apparently, both drinking and those, if you hold down Alt and you click it, it happens instantly. Which is kind of weird. But, you know, I'll take it. Now, life support is at 77%. That is okay. We swooshy there. And I do believe we saw a battery just hanging out here, too. Oh, that is true. I did draw it on paper. I spent some time trying to figure out, like, how would one actually link Harbies in a way that would make some kind of sense? And I do believe I figured it out. Well, put my alarms back to ordinary workday settings. Went fine. Then fell asleep a bit, it seems. But still. Well, ooh, that is very true. That reminded me. Our friend here needs his awkward showers. Yeah. Napzor truly is the Napzor as well, then, a master of naps. Yeah, we got the suits on. Perfect. I've gone through here once without the helmet on. I was very afraid. Oh, no, nothing bad happened, thankfully. Now we have a bunch of icy chips. Because we did play around with those last time. Yo, jump. This entire place needs to be properly reorganized soonish. I think at least one of my there we go. Tools was in straight up like zero battery situation. Two of them.
Waste tank caution.
That is true. We were building that freaking solar array. Now we had to run back here. Okay, so let's try to be semi-sensible. The welder's battery came here, so we can just vent out our mouth farts. Then we have a quick look-see again at our tools. So we just checked. Welder is fine. Yeah, this guy's at 35. Now we got welder is good, we got a tablet is good, or even a labeler is fine, our angle grinder is acceptable, our hand drill is doing good, and the flappy toppy is doing a-okay as well. Now the nuclear battery, we have one over at the ogre and one there in the charger. Our oxygen could be replaced. No. I mean, we're gonna probably have to... Yeah, we're going to do this anyway. That's fine. I'm just wondering if we did a little silly business with this. And... there we go. We look inside this one and this one, which should be yellow, but I still haven't got around to it. And I only have an active vent. With a liquid drain to drain the waters, we got this thing with this wireless battery getting infinitely charged. We have a computer locker. I do have some stackers at the ready. Iron walls, which should get shredded. Old jetpack, mining belt, a little bit of paint, Sterling, couple of more Sterling engines, the old welding torch, portables connector, portable liquid tank Mark II. Yeah, we have uses for most, if not all of these. And the old furnace. Right. So then with a passive vent. We don't have any iron. We don't have any iron, do we? Like at all. You're empty, so we can turn you guys off. Now we do... Get that liquid drain. Wait, I got 2 liquid drains. That's less than ideal. Oh. Yeah, and it actually shit. Hey, perfect. I need more of those passive vents. We got a whole bunch of gold, some coal. Hey, don't do that. Coal and some... We do have a little bit of iron here. I like that it's uranium, but it's absolutely useless. Other than for producing, I believe, pollutants. So it off-gases like a lot. So it's handy for that. Other than that, not much else. Then we have a look-see here. That one's empty. That one's empty. Heckin' perfect. We look inside. Not here. Not there. You are... Monowaterized. Then we got nitrize, oxide, volatiles, and a lot of pure pollutants and carbon dioxide and nitrous oxide. We can use all of those at in a later episode. But we got them the Muhammad Yaxos, as they say. Excellent. You're going in a charger, and we're putting the nuclear battery in our arc welder. We're gonna first run through the ogre, check what the situation is there, because the game might have spewed out a whole bunch of ores in the ground, but it might also have already deleted said ores. Now those 2 are empty, mostly. Now there's a little bit of water in it, which we need to put in the watering machine. I'm gonna change this one out so we have 1 full battery with us. We check in here, we look at the arc welder, and voila, it has a freaking nuclear battery. Our second nuclear battery is currently way out there. laptop gets a full battery. There we go. And yeah, I want to make a... I think there was a power controller in the console, which you can link to multiple devices, and you could be like, hey, turn off all these devices, please. And have a general on-off switch for all of this. Which is, what we deal with eventually, once we get there. I'm starting to get excited about how, or like wondering how I'll make this room work. We'll have ore processing happens down here. We'll have ore storage over there on that side. Yeah, the ore storage would be next to the place where we have the advanced furnace, and then from there we have like ingot storage, and the ingot storage would be leading here, because the pictures of the base that was shared last stream on the Discord, they look so freaking amazing. I was heckin' jealous. Oh, and quickie, let's see here. There's so many seeds. 41. It won't fit neat, like split neat, but it'll split acceptably. Because there was no plants growing. So again, good old ADHD freaking confusion. But I really do feel like we should have these things doing at least something. So we do split half, chuck half, split half, and we got 4. How do we... 1, 2... And we can't do 10 per, so... Here, have 8. No. Have 8. Sure, 7. We'll do half. You get 7. Split half. You get 7 or 6. There we go. I guess you have some automation for the grow light. Yes, the grow light is... See, we have a greenhouse daylight sensor, and it's inside. Because first I did outside, and then people pointed out that, its solar irradiance will be 0 because it's inside. So you can't see, it can't measure how much sun is hitting it. But we do get the horizontal and vertical information. The same ones we're similarly using a system out here to control my clock, essentially. So I'm getting the vertical information, which is how high it is. How high is the sun? If the value is below 90, it's daytime. It's above the horizon. So this one is just looking at this thing. And if the horizontal value is smaller than my target value, the light should be on. Now some of these want a slightly longer day than what we got here, and it's not quite as efficient as the sun, which would be better if we had, just access to the, through windows. Like on Mars, for example, you have pretty okay sunlight, so you can also skip your grow light by just building a couple of windows and your plants in front of it, and let the sun do the job for you. Yeah. The arms are happy. Well, technically, I think the arms are... They don't have much of too many feelings about the situation, but the plant beneath them is happy. But then they turn unhappy if it's, not doing that well, and then, of course, there's a sad little dead face when it's dead. Sorry about that. Yeah, and my current target is at like 90... I think at 95, but I think it should probably up it to like 97. These are Harveys. There's a Harvey here, let's see. There you go. Take wheat. It doesn't really say. Yeah. F1. The Harvey. An input slot and an output slot. So I'm manually inputting seeds or plants for them to plant for me. And there's chutes on the backs of the output, so the output is automatically going here, through the roof here, over to the refrigerated vending machine that I built. Normal vending machine, the food would rot a bit too fast, but a refrigerated one, well, it'll last a little longer there. I should add a sorter in between to identify, like, are these seeds? If they're seeds, then put them somewhere else, because they don't need to be in the fridge. As an import, export, and a hand. Now, I still want to make these work better with the chutes, but there is a more advanced version. Because those are for the... They can't move. They're just above a plant, right? And it's a good idea to have there's the version of your planting thingamabob. There's the, I think, the hydroponics device, which is similar to a hydroponic tray, except it has a data output, which you might see there. So that way we can read if there is a plant inside. Like if there's nothing inside here, then the Harvey should try to do a planting if it has something in the input. And then we can also measure, is the plant mature and is it seeding? So currently it waits for, it detects it's mature and then, it doesn't really do anything yet. But if it's also seeding, that means we start harvesting. And then I have a looping, and then a loop in the code where it keeps on taking the harvest action until the tray is empty. At least it should do that. Every now and then it has a little bit of a brain fart and just stops working. And then there's the Larry, where instead of having multiple devices, what you build are these wonderful like long rails back and forth. It flies about, and you build these stations for it. The Larry dock. There's a collector, a cargo, hydroponics. The Larry kit, which would be the more advanced one, yeah. So, but that one will then allow for the linear articulated rail entity. All Larry can be used to plant, harvest, and fertilize plants in plant trays. You can also grab items from a chute export bin and drop them in a chute import bin. Larry can interact with plant trays or chute bins built under a linear rail station or built under its dock. So that way we'll have an arm that moves around, picks up things, puts them down. And like it mentions then, you can also do the fertilizing, which I haven't messed with fertilizers at all yet. You do those in the composters, be careful, they also produce volatiles, so they need good ventilation. And has an arm slot. And it can do then more complex things, has more complex logic. Now if we go back here, Larry Dock Atmos. The atmospheric Larry can pump gas into and out of its storage canister. And when lowered over a passive vent, the atmospheric Larry will connect with it and pump gas into and out of the connected pipe network. Pressing the activate button while the Larry arm is at its home dock will move the arm off the main rail. This allows other arms on the same rail to pass by. Ooh. Oh, cool. So, okay, with these dock things, they can all go into parking. So we can have like one large rail, but have one Larry active at a time. Because these things can crash into the player and things in general. And if they do that, well, they get sad. And the player might get very sad as well, I think. I don't know. I've never built these things. And the base atmospheric logic values point to Larry's internal gas storage. The input atmospheric logic values point to the grid that Larry is in or the pipe network, and Larry is docked to by a passive vent. Okay. And how large? And has slots for a filter. Build states. Larry Dock Atmos. Electronic parts. There's an atmospheric Larry. Modes, logic. We can have a filter. The atmospheric Larry can pump gas into and out of its storage canister. When lowered over a passive vent, the atmospheric Larry will connect with it and pump gas into or out of. Okay, so you could have a greenhouse and have a Larry deliver batches of carbon dioxide or something into it. And because of how the Larry works, if I've understood correctly, they could then pick up things. Now this one has a slot only for a filter. So is there like a Atmos? A normal Larry dock? What else we got? Dock for cargo. The cargo Larry can take things out of and put things into slots on devices. The dial on the front panel indicates which slots on the device to interact with. The slot value variables on the item in the slot can be read using the proxy slot index 255. Pressing the activate button while the Larry arm is at its home dock will move the arm off the main rail. Okay, so we can have multiple of these on one rail. Okay. So you can put things into slots in other devices. This sounds like it could be used to like change filters inside filtration devices. Dude, that's cool. Holy shit. Because wondering like, well, then that's the problem with filtration, because eventually you always have to go check like, oh, do I need to do something about this? I should connect those to a logic and light network as well and have them be able to signal like, hey, yo, blinky blinky. The filters need changing in, carbon dioxide filtration. Heckin' amazing. Oh man, I can't wait to get into Larry's. How about the collector? The collector Larry can suck up those nearby loose items when its mode is set to inward and eject stored items when its mode is set to outward. When the stack to suck up items and the collector Larry will automatically stop and retract when full. Pressing the activate button while the Larry arm is at its home dock. Oh, it has like 19 storage slots. And it can pick up loose items. Okay. I was wondering, like, when would we need this? Well, hello there, Balin Alaman. Over on the YouTube side, the collector Larry sounds good for a chicken coop. Holy butt nugs, Balin, that's a good point. That is a very good point. So I was thinking about when would I use this, and I was thinking, well, if I instead of wanting, I could essentially design a system where we have a loader with a cardboard box, and I want that cardboard box to contain a number of different items. Then I could have the different manufacturers manufacture these items. They could into their stackers. Full stack is done. They get popped out. And then similarly, like I have my like silly system there to recognize when something's done. We could have like a pressure plate in front of it. It lands on the pressure plate, informing the Larry here that the thing is done. So it'll go and pick it up, and then bring it over to the place where we have our the loader, and that way a sort of pre-designed inventory will be automatically created. Now, when would I need this? No idea. Well, hello there, Ratmos. Happy birthday once more. Hope you're doing well. Well, I hope you had a wonderful stream. I hope the noise tying went well. Well, this one seems handy, and I was wondering when it would, but yeah, exactly, the heckin' chicken coop. Because wondering, like, I don't want to run around and pick up heckin' eggs, but if we get a collector to suck up those chicken eggs, well, now that sounds like a good time. And also, if it can and eject stored items when the mode is set outward, so we can use the Larry to both collect eggs from the chickens and, like, throw out food for them as well. We're not going to bear trap most. Noted. Nice. That's very cool. What about the hydroponics one then? The specialized. The hydroponics Larry can plant and harvest plants as well as place fertilizer into the plant trays. It has an additional hopper slot which will feed items into the hand slots when the hand slot is empty. Harvesting a different plant while the hand slot is full will be possible if the hopper slot is empty. Okay, so it has its own like one temporary slot in there, in which case the plant in the hand will be moved into the hopper slot and the new plant will be harvested into the hand slot. The variables of the plant in the plant tray below can be read using the proxy in the slot index 255. Pressing the activate button while the Larry arm is at its home dock will move the arm off the main rail. This sounds like we could have a bit of a simpler time making the logic for using plants to harvest themselves. So if you have the Larry dock, hydroponics, it goes to harvest the plant. First it picks up the seed. It brings it to the drop-off point. It goes back, picks up the plant. And then if its internal hopper is empty, it picks up the plant in the next one, filling it the internal hopper. And then it goes to drop off that one. And it keeps on doing this until the plant has been, completely harvested. Then it returns to where it was, grabs the plant from the internal hopper, and plants that one back. And this way we don't need to use seed to plant because, well, I want to make sure we have a large backup amount of backup seeds, pretty much. Keep on making more seeds. Yeah, I'm getting excited about trying to build the giant thingy for a larger greenhouse. But before we get to the Larry, we got to make our more complex Harvey system just because. A bedtime snack? Nice. That team was awesome. Oh, glad to hear it, Ratmos. Wow. Larry really seems nice. And you have your basic Larry, which can do the same things as the hydroponic one. So your basic Larry can actually do a lot of stuff, and then there's specialized Larrys. Well, we'll get there eventually. The dock bypass cargo. The Atmos feels funny, but I guess we could use, if you have like I said, you can have an atmospheric one, just bring gas to places instead of having everything piped together. Consume the bread loaf. Have a weird cheaty drink, and we run off again. Because we came here to do something. Yeah, plants. And we did that. Excellent. Infinite distraction time. Oh, yeah. Is that a hot dog on your shirt? Yes, it is. It's hot dog lightning bolts. Perhaps I might recognize the company as well. It's the Biltema Curve. It's from a Swedish hardware store, essentially. Sells car parts and stuff. Ah, the Wolf's weenie. Nice one. Let's pretend I have everything I need with me. And if not, then, well, I'll be problems for another time. Let's quick look see here. The silo is still empty. I'll deal with you at some point. So a quick looky at the ogre, which might be done. If we're lucky. And a Swedish car parts store sells hot dogs. Mm-hmm. Well, this one does. They sell car parts and, workwear, nails, just general hardware stuff. I think with the name Biltema, I think they started out with car parts, but then they still sell car parts, but they obviously expand into all kind of stuff. They also sell, then candies and snacks, and they recently started their own cafe there as well. I think they've had that in Sweden for a while, but they finally came to Finland as well. The Biltema Cafe. And I gotta say, very competitively priced. Nowadays, fast food everywhere is extremely expensive. And they sell, burgers and things, and they're proud of their hot dogs, it seems. And, they were quite nice. And it's true, they sell many things, though. Hardware and stuff, bicycle thingies, car parts, things, yeah. There's some wood items. There's clothing like this one, and then the workwear. For like high visibility, some safety stuff, and then things for your garden, inflatable bathtubs, kiddie pools, many things. I like them as a store. Like a good quality shit most of the time, or at least acceptable. And their food has been remarkably good, considering the fact that it is a sort of relatively cheap food that they sell. In fact, that actually it's one of those funny things where it's kind of like the cheapest place to get a burger, and it's actually quite good. Always a lovely combo. I, of course, knew about Biltema, but did not know there was a merch for the hot dog. Yeah. I love this. Yeah. Over at most. I love it even more, trust me. I hope it catches on. Yeah. Yeah, and the food stuff is understandable because, there's a lot of workmen that come there during the day, and now they can also go there for lunch. And, like I said, their food quality is surprisingly good. The, quality to price ratio is really, really good. Ooh, you found a little bit of silicon. How are you otherwise? You're dead. Now, I would like for this tunnel to just keep going. But I also wonder if we... Oh, right, I was supposed to dump that off. Oh, well. Now if I do pom. Yeah. Oh, no. You're totally in the wrong pocket there, friendo. Totally in the wrong pocket. Come here, you ogre. There we go. Then we change cartridge. That'll work. Just think of IKEA, the original hot dog at the in-store seller. That's very true. I think you folks are onto something. I think they might be. Heckin' Swedes. Ah, see, I wanted a hole out of the mountainside, and I have achieved it. Okay. Where's my notes? 1456 and 750. See, iron, copper, silver right here. Well, we could do a couple of solar panels. But yeah. I wanted access to this. Ooh. Iron, copper, silicon. This is this place I wanted. For my next deep miner. And then we got nickel, silver, lead down the hill here. Not bad. Not bad at all. SNL. So, next outpost will be built here. We need a large amount of iron so we can build all them chutes, connect these places together. We'll have obviously some local power production. But now we need to get back to the original plan of finishing up with the... Oh. Let's snag this one. I'll put you there. One wrench. And one angled grindy boy. Wow. And was the location codes I gave you a while ago? Yes. Or at least close by. Close enough. That's where I was aiming for, because I went there myself as well, and try to find something that would be in a orthogonal line from the tunnel I was digging with the ogre. And now I've got a continuous ogre tunnel all the way there, goes up and then it exits the mountain from the side there. So that'll be lovely. We'll have deep miners there, and possibly as well we'll continue building further down. Or not. I don't know, how good is freaking Amy at climbing hills? Well, maybe we'll find out, because that could be a good location for Amy as well, because the main base has the problem of being, well, riddled with holes, the terrain around it. And I have no idea how good Amy would be at navigating all that. I'm assuming kind of shite. Now we gotta run. Gotta make our way all the way downtown. To the solar array area and see how that works out. Because we got a bunch of the frames down, we got walls. Yeah, we need more. Did we need more steel frames? I can't remember. Ooh, and rightmost. Not only is it a hot dog, by the way, on a t-shirt. It's glitter. It's a glitter hot dog on a t-shirt. Golden glitter. It's freaking lovely. I didn't know. But this whole section of Bieltema web for the Bieltema Hut clothing. Yeah, it seems relatively new, I guess, because the first time I ever saw these were this summer. So I think they've really leaned into the Bieltema Kurv. Which is, Swedish for sausage, korv. And then puts an ö instead. Or the t-shirt must be a special edition or something. Did not see it. A glitter hot dog. Yeah, I saw it during the summer. I had to get it. And it's one of my favorites. I love it far more than the missus does because, well, glitter bombs are never fun. But I like my glitter hot dog. Brings me much joy. We'll deal with this at some point. We do need one of these transformers. Oh, that's cool. Oh. Have I finally run out of power? Let's go find out. I think I have. This is exciting. Yeah. Which means there probably isn't... There's a storm not too far away, is my guess. I don't know how, typical masculinity might be different there than it is here, but I love that an automotive/hardware store selling glittery hot dog swag. I'd say the glittery hot dog swag being used in that way is more of a modern thing. The whole ironic nature of it. You got a glittery hot dog with lightning bolts. It's one of those things that's cool, ironically. Nice, you got power. If I turn you all on. Your pressure is... Oh. I found it. It is a special t-shirt. T-shirt special. Bieltema Kurv. Grandfathers might not approve. I don't know. Some of them might not. Others would just laugh because it's silly. Now this one. And in this one, yeah, there we go. Pipe valves. So we need condensation valve. Can't do it there. Thing is, I need... Oh, I can do just... Okay, we can do it here, right? Then we can have we have the inputs and the outputs separated. We have that should be easy enough. Do grandfathers not have humor? Apparently not where... Tragically enough, yeah, no, Rathbone seems to live in a non-humored grandfathers area. Tragic fate for grandfathers everywhere. Okay, so now the input. And then we need one more valve, which goes in between here. The one-way valve. My nemesis. Like that. And just... Now we open that one. Because this way, the output gas will come through here. If we ever need to, we can turn it off. But the point is just the input won't be flowing into the output, because output will be cooler than the input. But the input will eventually also cool down enough to start turning liquid again, and that's why we have the condensation valve, which is the very point of this, to turn the steam that we're producing into gas. There's a large contingent of grandfathers here who disapprove of boys wearing glitter, full stop. Interesting, it seems that the special t-shirt is not listed when you browse. Had to Google for it. I guess it is too powerful. Could be. And also just a limited edition thing, because if they don't have it on the store right now, because we found it with the missus in the store, I thought this is just hilarious. It is just, it is so kitsch. It is so, the opposite. Like, yeah, golden glitter, and it's freaking BLTM, like car hardwares, and a hot dog. And like, that is just, I love it. I need to have it. It's right up there with, things being like beautifully, horrifyingly kitsch. Now you're getting still charged, but let's not question that. Exclusive hot dog club. Delightful. I do like it. I always find it weird when sometimes someone gets like super like macho masculine about stuff, and like in like a weird way. Because it's like no, it's okay to be masculine and still enjoy life, It's okay to like nice things. It'll be a different thing if it was like glitter shirt with like, I don't know, Hello Kitty. I can see like some grandfathers disapproving of that one heavily, but not that many. You know what? I realize the thing is, because at least in Finland, and I'm assuming Sweden has the same thing, our culture is very big on making fun of ourselves. Like, Finland is known for being very depressing, and we make a lot of fun about being very depressed and depressing. And so, the darkness and so on. So there is a lot of self-irony here, which is like just being part of the humor, creative art for a long time. And did you know that Hello Kitty is not a cat? And oh yeah, the US has no sense of humor about itself. Oh. Yeah. Now, Finnish humor is usually, it's, what they say, gallows humor. It's very dark, traditionally. There's a lot of like, so Christmas songs where, so on, there's music that sounds peppy and upbeat, but the words are extremely depressing. And so on. And that's also why I think, yeah, like, a lot of the grandpas here will be more than okay. So we have a pressure valve, and that pushes this gas into there to maintain a pressure, but it is currently way above that pressure. So it should be more than fine. The Balgatan. So, gata is Swedish for, like a road, street. So the Balgatan Pass is just like Ball Street Pass. There we go. Liquid tank small insulated. Pressure high for 52 liters of liquid, capacity for 6,000 liters, and 52 of those are water. The rest is gases. We could try to purge from there, and we will eventually, but right now we just need to not explode shit. And we need more power. And we can do that using these magical machines. We can fit more, more of these Stirling engines. Slowly but surely, pumping along. See, now we have multiple purge valves. They're producing power. The pressure inside here is going down. Temp here is 570, and on the other side we're at 550. Okay, good. So now we have a very clear sort of temperature difference here. And eventually it'll get low enough so the water will start condensing, the steam, into water. That goes a long way to explaining the difference, I think. I think so, yeah, and it's a mystery. And however, one of my grandfathers would maybe not think all the glitter and stuff would be that funny. Not sure. Yeah, I mean, there's always individuals, Not everyone follows whatever, their culture they're part of, like, wholeheartedly. Everyone is unique. Not everyone likes the same things. Some people are more closed-minded, some people are more open-minded, some people just have different tastes. It's fine. Okay. So there's the pressure. Now, you're on. Oh, you're not on, that's why. Now that guy's on. Oh, you're just straight up empty. Well, then I can leave you on for a while, because... Well, pressure's low, but temperature... it's fine. Look at the number here, it is actually producing power though, so... That's A-okay. In the meantime, this guy has a bunch of volatiles. This one is controlled by magic. It will be once we turn that one on. See? It is adjusting for the temperature of the oxygen and the volatiles, which is very stable, but the outside temperature keeps on changing, and the oxygen, because the atmosphere here is pure oxygen. It's not very thick, but it is acceptable. So if I turn you on, and you, and then this thing start working, before we forget, and cause an explosion, I'm going to turn you on. Pressure's going down. See, there's water in the pipes now, which is stressing the gas pipes, so they do not like liquids. No siree, no they do not. Oh, right, yeah, there's still molds and stuff in here, which is also hot stuff. Oh yeah, because I had to suck him out from the pipes, because I was almost causing an explosion not too long ago. Also almost got the water out. This thing is getting... The pressure is increasing very quickly, but that is because the temperature is over 2,000 degrees Celsius. So even if there's not technically that many moles in there, they're very expanded. Very big. These are... With the water's out. So now I could... see about... 14.9, 14.7. Their volume's going in, it's not too insane. Yeah, I need to still add a detection system here where it would detect the pressure inside this tank, the state of that machine and so on, and this pump, so that if that machine is on, this pump should be on, as is the fuel production. And they should all be open when this thing has a pressure below target set point. When it reaches that set point... Ooh, hello there, Mist. How you doing? Nice seeing you around, friend. And... Boom. And then Balin Element saying, Hanu, a way to free filter on your Europa is use Europa's. Is use Europa. It's the way I filter CO2 pollution. Yeah, the coldness. Yeah. The temperature difference and so on. Yeah, I've been meaning to build a system that would be more like temperature specific. But right now, seeing as we can produce very hot things and we want to filter those down into water, might as well, use the Stirling engine to, produce power while doing it. I just need to slap down one more Stirling engine here in the middle and on the side, because we do have 2 more. I'd kind of do it now, right now, couldn't I? Alright, now pressure's going down nice and slow like. This is going up. 42, 42. Alright, let's go about 45-ish. We'll turn that one off. But I guess it is true, it really depends on a countries and society's ability to laugh at themselves. $47. It's good enough for me. Alright. I have a 1x1x1 open with a manual hatch and an open wall. A condensation drain in the room. When the liquid leaks out, they instantly freeze. Then have a hopper at it to collect. Ooh. That is a pretty neat trick there, Balin Element. Yeah. Yeah, so the condensation valve just leaks into something and yeah. So I was just thinking like we do this and then we'll use a purge valve to pump the gases out and then we can filter that shit. By turning all that into their individual ice things. Not a bad idea at all, because we can still get you can use the heat from this thing or the heat from, I don't know, gas of your choice, I guess. The temperature is a little low, but the pressure is okay. Now, yeah, the pressure currently is at 40, so if I turn you on. The target is currently at 40, so now we go below 40. This one keeps on allowing small amounts, which should be then hopefully increasing the temperature. I guess it is, but very small, in very, very small amounts. There's a stress number that is increasing, actually. And they're surviving volatiles. Are you telling me there's not enough oxygen in here? There you go, now it's properly burning. I'm at 28 megapascals. How about you, my friend? You are at 10.9 kilomoles, on that we A-okay. You're doing your best. Now, of course, I do believe this would be more efficient, faster, if we had a pump sucking in oxygen into like an inline tank in between here to maintain that pressure. Because right now, I think it is the low pressure of the oxygen that is slowing down the fuel production here. 1.2 megapascals, and I think this one could be producing stuff slightly faster. But it's working, and that is a-okay. And this one is just here to, make sure that stuff gets drained so we don't have, things turning liquid here, because the machine itself is not insulated. So things inside here will cool down rather quickly, actually. That's why we need this one. Hectopascals. I know, right? God dang, right, most. So many heckin' pascals, or megapascals, and kilopascals, and freaking gigapascals at times. So much pascals. Alright, so the water's gone. There's still some couple of moles of water in here. The temp is kind of low. Well, that temp is also getting a little too low. So, how about we clickety-clackety do that? Nah, it's fine.
Power critical.
So now this pipe network is being drained nice and quick, like so is this one. Hey, Space Andrew Gaming. I'm assuming you know gas transfer to a tank is not instant. Yeah. Goes through the pipe. That's why I'm looking at the pipe here. And slowly go collecting in here. So now we got this thing at... Oh yeah, they're freezing. The hell? The machines are using power faster than we are producing. Alright, here. How about heckin' nuclear battery? Go nuts. Power! Mm-hmm. Now, everything is functional. These guys are producing a lot more power now. Oh shit! Well, that's fine. It's fine. There you go. Blast it over to 40 and then slow it down again. Yeah, it's trying to maintain 40. At least it should be trying to. So, whole bunch of heat again. You have recharged. There we go. Now we're again producing power. More than we're using. Excellent. Okay, so this one can pretty much keep on going for a long time. The problem I have is that eventually we need to get rid of, you know, the gas in the pipe. Right now there's a little bit of water, and the water is evaporating. But there's also the drain pipes, which I'm assuming would mean that... Three megapascals pressure there, 3 megapascals here. So okay, we're getting the water slowly but surely So what I would want is some kind of, well, proper purge logic, I guess. Right now the thing is just, I don't know, here. To collect the gas. Lots of a drinky. Alright. I'll be doing its best to maintain that pressure. But if I run away, I'll leave it be. Eventually, it'll burst the pipes. Because they'll freeze. As such, we would need, pump valve thing to detect when the gas, if there's a minimum temperature limit, if we reach that, we'll jump into a separate loop where we void the pipes. And then start putting in more hot gas, pretty much. Because we can't just infinitely keep on putting in hot gas like this, because, well, it will just... Because we're looping through here. We're trying to cool it down. So it's looping in here. Now we got this one-way valve in between here, so we see that's one at 1,000 Celsius. Here we're at 1,030. Now, I don't think the purge valves will save us from ourselves. But more cooling from the Stirlings is place them in series. The first you go drop by 800, the second by 400 Celsius more-ish. Well, thank you, Benny and Element. That's a good point. That would be interesting, I guess. Rather than having in parallel like this, having lead into each other. You might get less power from them, though. Yeah, I'm assuming as much. That's what I'm thinking. This could be a better way to just have them, cool and produce power. So we get like 2 for 1. So if we do this... And then, yeah, like I said, have another sort of emergency logic loop, because this one is at 12.9 megapascals.
Hydration
Oh!
critical.
Pressure is actually increasing, even though this thing is... Oh, because it's barely putting anything in here. And the temperature is at 800. So we're reaching sort of maximum... Let's say safe pressures. Yeah, have a detection system for when the temperature goes below something. And when that happens, the engines turn off. We vacuum, we void out the pipes. Straight up parallel equals more power, less cooling. Series, less power, more cooling. Yeah. It's not really a trade-off, because you get the same amount of cooling eventually. It's just, how quickly do you need your cooling to happen? Alien element on the YouTube side. Now I think this one... Alright, we'll have to do this in order. Where we turn you off first. You have run out of fuel. This pipe network is empty. Turn you off. You are going to be doing A-OK for a while. Wondering what happened there. Is it the O2 and the volatiles started producing too much gas? Yeah, well, it was a zero where it should be. I'm assuming, yeah, it got some unburned fuel in there. And as a suggestion, I thought about why not put a H2 combustor in a box. And is string cheese coming in Finland? No. The only reason I even know about is string cheese is TV. Hollywood has taught me of your sinful ways over there. And I'm assuming string cheese is the stuff that you get comes in the spray can, right? Now the closest we have that to that is sort of decorative plastic stuff. Okay. Health is going down. I mean, health will be going down soon. Temperature here is at 600. Input is at 670. They're very close to each other. Unburned fuel mixture has somehow survived. At this point, I'm also wondering, like, should I have a emergency pipe igniter attached to these pipes as well, so that if there's fuel mixture in the pipe, we can just ignite that bastard. And what's your opinion on Hawaiian pizza? Delicious. And string cheese is a mozzarella cheese packaged in the shape of a rod. You can peel it apart into strings. The goo in a can is spray cheese. Oh, that's true. That is yes, spray cheese. Yeah. See, once you said it, it feels. I feel silly and stupid for not making the obvious connection that, as you know, what you call cheese in a spray can. Spray cheese. Okay, we can leave those alone for now, because we're about to die from hunger, so let's go deal with that one. And Cheese Whiz is the common brand. Ah. But yeah, cheese strings, mozzarella that you can just peel into strings. Now, I think most of the mozzarella I've seen sold is sold in spherical form. Yeah, we need to get in there and also check on our batteries eventually. But first we need to do the whole not dying thing. And putting your H2 combustor inside a box is something I have not done on account of, you know, it producing crazy amounts of heat and stuff. I mean, silly string is goo in a can that sprays out into strings. I don't say that's a very reasonable cross-up. Alright, so there we did it. Now we're no longer doing the dyeing. We empty our mouth farts to feed the plants. Put on the helmet. We turn off the lights. We do nice quick reset. There we go. So hopefully they haven't run out of power, but yeah, you never know. And spray cheese sounds like an evil that's beyond my ability to describe. I would agree, Depot. How are you doing? Hope you're doing well there, over in Kiwi land. Yeah, I forgot about this one too. Okay, let's see if we can finish this shenanigan, because we were like literally running around to get this thing quickly done, and then I just immediately forgot about it. I do believe I put it somewhere, hopefully sensible. There we go. No. There you were. Now, I'm going to turn you off. And I'm gonna cause a little bit of a gas explosion. There we go. Gonna have a little quickie look-see here. Because I believe this canister is already here. Would be. There's an oxygen. How the hell are you empty? That makes no sense. Well, let's not question it too much. Now, what I need next is to do this one. The HU combustor. Oh, string cheese is a cheese shaped like a hot dog. Mmm. It does sound pretty tasty, though. And the H2 combustor is a box. Could be a bad idea, ammo. Unless you're desperate for a heating source. Yeah, I was wondering the same thing, Balin Element. Because the H2 combustor otherwise seems nice, but, you know, yeah, like I said, it produces crazy amounts of heat and might cause off gases and things. So just having it just there works just as fine. So like I said, the only risk that it would, as far as I can imagine it facing from being where it was, would be from, you know, liquids cooling too much inside. And that is something that we're dealing with by the magic of having that turbo pump. So when it turns off, it gets voided very quickly. All vacuumed out. There we go. Active vent. And we'll do a mildly silly thing. Should have. We got heavy cable. Oh my god, it did have a normal cable. Thank the Jeebus. Now, then you go back. Close these. There we go. And that's oxygen. Very cold. So we can do this. And I want oxygen to go in here, so now we... put many moles in here. And the main purpose of the H2 is to make water. They need to cool it down to be usable. In a box, its output gas would be super hot. I fear to it, Balin. Now pressure goes here. But it maintains only 18.3, which is enough for that guy to turn blue. And this one will be filled with nothing but oxygen. Heckin' wonderful. So then we can finally, after this tank is done, we don't have to worry about our nitrogen filtration anymore. CO2 though. Iron, silver, and Constantin. Just realized, like, oh no, we're running out of power, and I have all these machines on doing nothing. Oh, incredibly wasteful of me. Okay, batteries are being drained again. That's like the wind failed me that badly. Seems like it. Now we needed a way to get rid of the gas. Cool down a bit too much. Oh well. We should be fine. For a while at least. And balancing out, remember on Titan, my H2 computer output was 1650 Celsius versus the normal 24,000 because Titan consumed a lot of it, the thermal energy. H2 combustor, yeah. I can imagine that, Balin. I see you ran out here, and then I remembered I forgot to bring the thingy-mabobs now, didn't I? Which was... What's your thingy-mabobs, you might ask? Well, I got more Stirling engines here. At least I should have. Alright, 2 more. We should have, hopefully, enough pipes. Hopefully enough computer parts. And all the other fun things. Alright. I gotta do something about this. Let's see here. We do number 4. We do this one. Put you there. I'll grab you. Wait. No. Set flatten. There we go. Now it's slightly easier to get in front of these things. Now my idea was to pull the cables this way. Now let's see here. Close you, number 5. There's one, and the end of the red one we go. Nope, you're empty. Alright, removing them from the logic network as is fine because, well, they ain't doing anything in here. Come on. There we go. Yeah, but seeing as we're getting some power issues here, it seems like the project I should be working on, which is the solar power array over there on that mountain, really does need to get worked on. And for that, yes, we'll be needing the transformers. We need at least one small transformer. Welding torch and 2 steely sheeties. We do pump and now we and then we hope we actually have some electronic parts. I feel like I should have some. I feel like I made a large amount and I difficulty believing I've actually used them all. Solar panels, And yet, looking all a little less than ideal. One has cables. This one has APCs and battery. It's only 4, so it's now nothing possible. I'm just widely annoyed at having this memory of making a large amount of them, and all I've done since then is... Okay, I did build a new... Alright. And power issues. GFG. Keeps box 55 to 50 Celsius and pressure 2 to 100 kilopascal. You got fuel mixing already. Gas fuel generator. That's very true. Ooh. I missed some chat here. Yeah, okay. Read about the cheese whiz. Yes, yes. The string is good. And can again put in the strings. Yes, yes. Spray cheese sounds an evil. And it's dreadful. So it's both stringed cheese and a spray can cheese. Yeah, string cheese has a similar trade value in grade school as cigarettes do in the military. Ah. Neat. Correct. And this sounds unhealthy for several reasons. It is. But I gotta admit, the more I hear about string cheese, the more intrigued I am. I'm like, I like mozzarella. And in a string form, it could be interesting. Because I do quite enjoy knowledge mozzarella. Like, you guess we sell like mozzarella balls in water kind of thing. Like, I think mozzarella is usually done. And you know, chop it up, put it in your food, put it on pizza, all that good stuff. Oh, pizza. I'm on a diet and it sucks. I'm hungry and I want the good stuff all the time. But I have lost a lot of weight, so that's nice. Now, let's see here. Oh, heck yeah. Okay, we need like 3 of these. No, fine. That's 1. 2. Wump. There we go. Oh. You're right, I should make the gas fuel generator, but I realized in between here, what I could also do is just throw in some coal in the old furnace. Now I have one. Why not make use of it? Oh, for now it is being used. To say poorly. What I should do is have this thing inside a vacuum. Because that way, I would know that everything I collect from that room would be carbon dioxide. Okay, carbon dioxide and pollutants. So, but the filtering of that one wouldn't be too bad. Being on a diet sounds like a thing, but then wouldn't have to. You know, meh. It's very true. An input pressure 100 kilopascals maximum for the fuel. A pressure regulator would do if its output pipe is 1 piece, 10 liters. Thank you, Balin. I'll keep that in mind. Where the heck did I put those? These guys. More Stirling engines have been Stirlinged into existence. And we do that. What was that one? This one and up in this one. Switch out. Let's go for a wrench. Okay, that's them outputs. I've got a little unhappy there. They're better now. There we go. A bit much pressure. Yes. Above 50 megapascals, they start screaming like that a little bit. Wait, is that an X piece? Looks like it. Let's fix it. There, that looks better. So now the pressure there is fine. Still need to cool down a little. I don't want, because I don't have any like check yet for making sure this thing doesn't get overfilled, so we're not gonna, otherwise I'd probably leave that on while I go do other shit. I really should. If you're feeling froggy, use nose fuel for the GFG. Thank you, Bailey and Element on the YouTube side. I'll consider it. We'll have to build that one far away from the base then. If I try to make that happen, I'm gonna blow that thing up so bad. Oh yeah. Making explosions. Well, that thing's producing fuel and also giving us some CO2. The gas one, the gas operated one would be better, I think. It's more fuel efficient. Plus degassing all that carbon into carbon dioxide would be more useful for other things. Now, what the hell am I here? Oh, right. We need tanks. We need iron, though. You don't have any iron at all. Well, easy fix. There we go. Weird amount of stuff. Fuel in there. How hot are you? More than hot enough. So, oh, before we do that, alright, it has finally been emptied. I'll open you up. There you go, melting the irons. The input gas is hot enough to melt it. There you go. Oh yeah, gotta close that one. So it doesn't input any more gas. Just outputs the gas. Goes in here. Pressure at 28 megapascals. They are E. Okay. This was a... oh right, yeah, we should do that thing as well. So, oh, well, good. We're going into that room soon. Only 2 of these. There you go, friend. Make an endless amount of making basic chutes, because we're going to need them. Because we found our new outpost position. Oh, wrong room. Yeah. Now we should hopefully have everything we need in here. Including a pump, pressure regulator, and all that jazz. Okay, now. You... see how this works. Okay, working just fine, see, because open the valve to cool down that gas. Now it'll cool down the gas that we're letting down through here. Well, mainly this one, but I guess as the pressure goes down, it would get more gas from up there. But this one way. Okay, we gotta have a little bit of a thinky poo here. So this thing's temperature is, as the measurement says, 468. This one should be and remains higher. Wonderful. So the one-way valve is in fact working. And this one will go to around 200 degrees Celsius, which is when that one will close that valve, activate the purge pump. So make sure nothing freezes inside here, because it's built in a silly way. Here's a very interesting. Is your pressure continuously increasing and your pressure is decreasing? Temperature remains the same, because we keep on getting more hot gas from here into here. Oh, there's a pressure difference anyway. This one's 5 megapascals. This is 3.5. That's fine. Yeah, because this one just has a limited amount of pass-through. Can't have an infinite amount of gas going like super fast. Well, eventually they'll equalize. Not that it really matters, to be honest. Because this was just a way to make cooling a little easier eventually when they go here. But then again, these are also cooled by external air, so... do I care? Should I care? Oh well. We're going to let it do its thing. Now, this thing is also functioning beautifully. I can love it. But we're going to have to snag some of those. There's only 755 moles? Well, that's okay. We only need 120 of those. We'll need this one. Okay, good. We'll do wrench. I might as well make it a little silly. And, oh wait, no. We'll need you at a later point in time, but not just yet. Then we dump open our pockets into our magical cardboard box pockets. No, not the red one. This one, which should be yellow, but it's like gray. So we need to work. Oh, yeah, one of those there. I was wondering, like, do I want them to be yellow or white? And I came to the conclusion that I don't know if I care. So we're going to let them exist as they are. We don't need we're going to use the volume pump rather than the turbo pump because, well, I'm afraid that the turbo pump will pump too hard. Yeah, that'll work. I have to make some ugly wiring. Well, that's okay. Thought I heard something weird, but I'm like, oh no, was that the game or the real world? I'm not sure. Either way, I'm terrified. Oh well, something will explode or they won't. Nothing can levitate in the air because it's magic. And that'll do. Then we grab Prey Advanced wire cutters. Put you there. Oh, we have those powered vents too. And I'm like so many like in between projects that I keep on forgetting about, and then getting distracted by the next shiny thing. But yeah, power stability is number 1. Though fully automating these Stirling engines, which I should do. I mean, we have everything set up, sure. Let's just do it. Alright. Everything here should work. Nope. There we go. That'll work. And I do believe the number was around 60 moles. That's what we got in the other ones. Where that?
Hunger caution.
402, 407. Keep on equalizing, keep on kind of working. Acceptable. Now I'm going to open you up. And this will keep on trying to cool down the gas that enters this space. These will do filtration. And eventually these will heat up. And those valves will open up for their local cooling. And these can remain hot. Hottentotten. And the hunger is caution. We'll go have a piece of bread soon enough. Just, there you go. Canister. You just want the mole amount be pretty much as close to 60 as we can get. Oh, 36, come on. 30, oh, we're up above 40. Six, 7. Yeah. Yeah, we need to be bringing down more volatiles here to crush into this tank as well. With a large amount of fuel. Alright, alright. There we go, 60 moles. Good night, gentlefolk. Well, thank you, Ratmos, for hanging out. I do appreciate it. And once again, happy and most wonderful of birthdays to you, most rattiest of rats, rat moist. And I hope you get wonderful sleep. And sleep well. But okay, this system works well because as these keep on filtering stuff out, they also lower the pressure here and also allowing stuff from up there to, well, flow down here. And in that tank we have O2, CO2, a large amount of CO2, which is nice, some nitrogen, which is nice. Pollutants, well, we'll deal with those. I have multiple kilomoles of shit. You're at 10 megapascals. You're at 1 megapascal. That's a lot of, you know, oh. Damn. Well, pressures are still low on these three. So that's all A, O, and K. Let us dismantle our little horror show here. Look at that, the cardboards of box. No. There you go, back to functioning correctly. There you go, and you go there. Did we... Not in here. Not in there. There we go. We'll do red. This one. There we go. Now we've got the working gases as well. Yeah, pre-cooling, post-cooling. And that way with these here also. Nice 200 degrees Celsius. And yeah, definitely need to go hunt down some more volatile ice to throw into here. We made a large amount of fuel for the furnace. Oh, I love that freaking rat moist emote. Where's this like no freaking Chad rat most? This one has 20 megapascals, so multiple kilomoles of fuel right in there. This guy's empty. Probably moving back to the other place. And this guy's just, yep, a whole bunch of fuel. Ready to go. Now if you had a digital valve or a pump in between there, that could also be pretty neat then for when we eventually... Yeah, I think a pump, a volume pump would be more than enough to, once we start automating this one, for controlling how much fuel goes inside, and then we can use the hot waste gases as the pressure in pretty much. One of the logic would first achieve the correct pressure with the hot exhaust.
Hydration critical.
Oh. There we go. Let's go here. Oh, and our hygiene is poor as well. We need a... And the plants aren't doing too hot. We'll create one, see, because they're getting too much sunlight, because the loop is broken again. They've been living in their eternal day. Well, they've kind of survived, so that's okay. It feels weird now that I learned how to drink from a water fountain in like one instant by alt-clicking it. Feels wrong. It's too powerful. Now we fix the hygiene. Yeah, at some point we're gonna have... What the friggity frack? See, that happens. Why would you do this? Why would you stop? No. The plants are unhappy, which I'm not very surprised about. Because they've been stuck in, they got, too much light. Not enough darkness. They also need their sleepies. Alright, come on. More, 2 more. You can do it. Big guy, I believe in you, Harvey. One more. See, that's what it's supposed to do. Why do you stop? Or why did you stop? You know, I was planting? There we go. Most peculiar. So, this one. Here you go. Enjoy your mouth farts. We'll change the battery. Get your... Yep, suit is doing now A-OK. Nitrogen filter is still surviving. Because even though there's a very minuscule, very teeny amount of nitrogen in our tank, it is continuously stressing the fuck out of our filter. I'll deal with that at some point. Yeah. Yeah. You're all fucked. It's okay. So I brought this piece of coal. Whoop! There you go. And I guess, yes. Next I should, once we're done with this, I guess. What the... Where's the air moving from? What is leaking and why? So that one. I think that one might be the fridge in the living quarters. No? It's the valve for these guys. They shouldn't open unless it gets warm in there. And I don't think it is that warm in there. And that's the fridge. And beneath the living quarters we have the... Where's the nitrogen coming from? Well, I mean, in my jetpack, of course. Ah. It's the cooling for my gas processing. That's what it is. Fixed. And hey, the Invisible G, happy affiliate. And oh shit, I think technically it's supposed to start tomorrow. But hey, thank you, Invisible G. Well, it showed me today. Well, we'll trust the computer. I mean... Depending on where you are in the world, I mean, you might already be in the 7th, I guess. Oh yeah, Sea Depot's already getting it too. So I'm guessing it's you have entered far enough into the future to be in the next day. I'm in 6th. Yeah, same here. But hey, thank you everyone. I was hoping to. Looks like it's working. Yeah. Yeah, I was wondering like if I should try to do something special tomorrow, but I keep on forgetting about it. For the affiliate anniversary. Feels wild that I've been doing this for over a year now. Very neat indeed. Yeah, don't put my freaking waste tank in there though. And we close that one. So this machine needs that one, and you need that one. So now, missing gas says, well, that is absolutely not true. Well, they are missing though is a connection to the actual power network. So let's fix that one before I do anything too stupid. So it looks very much like a mistake I would easily make. What the heck? Come on. Right. There you go. So, that leads to the batteries. Comes from here. And once we get them rolling, they'll be okay. Yeah, it was the lack of the electrical connection that was the issue there. Working gas is there. But before we turn them on, okay, now I kind of wish I would have. Okay, let's see here. Put you all the way over there. Now, they're all attached to this cable, but this cable isn't attached to anything. So, oh, and you're not, by the way. I guess from here we could do a left and through there, and then it will reach into our logical spaces. So that will be A, O, and K. Gotta catch you later. Hey, thanks for hanging out again, Bailey and Alamein on the YouTube side. I always appreciate it. You are a font of infinite knowledge. And I've gotten pretty good at the whole finding the where is the edge of, too much help and where is, just sensible information and guidance on stuff like, what are the like math equations and so on. Because I do not count, giving helping out with math equations to break too much on the whole software core thing. Because unknowns are just, I can't even know to ask about those kind of things. But now that I know they exist, I would have then, Google forth the math equations. Because I'm not. I think it's patently unfair to expect someone who's trying to do them things on their own to reinvent mathematical equations for balancing gas and so on. I'm like, if I could do that on the fly, midstream, wow, I should be working in a very different field. Would be interesting to see that happen though, if someone, would be mathematically so incredibly well inclined. They could just, write out some mega math, just like that. All right. Okay, so what all do we want to do? And do we want to control it all from our circuit here? Well, we can't control it all from our circuit here unless we do some batch writing. So we can potentially do that If we look inside this pocket, this one, and what do we have left? One switch, a couple of housings. Not quite enough, eh? We need an in-out one for a batch rider. And a batch rider it writes to all of our Sterling engines, their on state. Are they on or off? Because then that one can be linked into this one using the PIDs. Which I think would be the sensible thing to do. So, quick run back inside. Again. Yep. Hey, friendo. I hope sincerely that you have all the bits I need for my Logic IO. Oh, you do. Fucking wonderful. Make 3. The machines are so hungry. I can't even have them. Okay, we'll make it 4, apparently. I think 5 is the full stack, so... I'm so heckin' easily confused. Well, seeing as we're here... Not so quick. We pause here. We look at our logical logic chips here. Now we have some switches. We have... Alright. Reagent reader, kit, logic IO. Look here, so batch writer, excellent. So we're gonna just wire that one to like tell all the Sterling engines to, turn off. Or on. So we only need to write into this one a yes-no situation. Now what else do we need? Then we need... Are we doing any comparisons here? I think all comparisons will be happening in code. We can simply use these to see and hope pretty much that the batch writer and reader would be allow us to circumvent the fact that batch writing and reading can cause the game to lag a bit, which we saw with the Christmas lights. In fact, we just test that now. You know what? We're not gonna. I'm getting too distracted again. I was thinking like, hey, what if we then take those 4 the groups that we have in the game and we just rename them. I mean, slap down some batch writers for all of them. Get these guys out of iron. And that's okay. That's for when we start approaching the next outpost. Yeah. But it feels neat. Okay, so our battery systems could grow. But because they can carry the base pretty far. But I've been sort of dependent on storms happening and making me a lot of wind power. So now I need more backup systems. One of them being this one, which is also mainly used to, create water, to be honest. And then we're just, in order to cool down the hot steam, we might as well make use of the temperature difference and generate power. Which is what we're doing here. And, yeah. And then we'll... Well, currently we're just storing it all there. That's alright. We'll have to make a more sensible solution eventually for how to do it, yeah. I like Balin's idea of having this like event pretty much just pumping stuff out into a room that is exposed to the external atmosphere, or at least the coldness of it. That's perfectly liquid. And then they will freeze to ice and fall down into a hopper, which then puts them into, a chute network. And then they can be, crushed or individually deposited in various in various places. We can have that like separate small like smelting rooms, like the one I was talking about a few streams ago, where we can use frames to build a room that can withstand even large pressures. Just in case something was really, really bad. And that way, we can dump in ice and then pump in some warm enough gas to make it melt. And then as it melts, the pressure increases, and then there's a separate vent that sucks out the gas. Like for my ideas for volatile gas. So that rather than spending like electrical energy on an ice crusher, we just dump it in there and pump in some hot volatile gas to melt it all up. It needs to be like warm enough just because as they melt, they'll cool down, and then we keep on like circulating this gas essentially. You have a small amount being pumped in at all times, and all the excess being sucked out, and while everything melts in there. And we could heat it up with, waste. Use a temperature exchanger with, again, waste gases from the furnace, because we're going to be furnacing anyway, and keeps on producing large amounts of waste gas. So if we can figure out more places to store really hot gas, and shuttle it back and forth, should work. But yeah, first we'll do batch writer. We need well, it won't fit anywhere elegantly, so we'll just go there. Oh, well, sometimes elegance is overrated anyway. So we'll do this one and open up that pocket one more time. Then we close it. Open this one, we close that one. Open this one, we close that one. And grab our coil of cables and our wires of cutters. And we plug all these things together. Wonderful. And we're gonna rename this one. No mere batch writer. It'll be Sterling on state batch writer. And we screw these drivers. Oh, so we choose the inputs. Okay, let's see here. Oh, batch writer, pressure and PIDs, pipe, logic, turbo, IC, H2 gas, tank. All Stirling engines. Setting on state. And your input. Ooh, we don't even need to link this. You see, the circuit housing has a setting. Oh, but it doesn't have an output per se. Okay, let's have a closer look here. So the batch writer. Forces logic writing devices to rewrite value. Yeah, the required power, preference in name hash error on. So through logic we can't actually do much. Okay, so then we'd have to have a separate reader, something that is actively pushing out a value. Okay. How about a switch? Read write for the open. So I'm thinking a logic switch would then have a on-off state, and apparently we should be able to write into it. Let's find out. We do believe, yeah, nope. Logic switch. See, we had one. How about that lever? It looks like they're otherwise identical. But they do have... It's just an aesthetic. Wire cutter. And I want to see you. Deep miner for configuration. So it's open and setting value are both that one. You can only read the setting, but we can read and write the open. I'm assuming that would hopefully mean Have to rename the bastard. Sterling Archer? No, just on. Switch. On / off switch. Not like naming things, even though it's only switch here, just so it'll be still slightly more clear here as we go through all of this shit. Now, if I turn you... I'm going to turn them all on. And all off. Okay. We'll see how well this works out. I want to say it's close to 200-300. We'll see where the H2O starts. The steam starts liquefying. Okay, it's 30% steam. That's not bad, actually. And producing some power. Gonna be below 300, but is it closer to 200? We can have a little look-see here. This one is at temperature 237, so we're assuming it's close to that where it starts liquefying. There it is. It's already doing it. It's liquefying faster than we can get rid of it. But it is all turning into a liquid. Excellent. Okay. Okay, it's going on. It's doing all right. It's doing all right. Okay, 60 moles, 56 moles. Stress is low, stress is going down. And temperature, pressure are so low, they're not really doing much of anything. Excellent. So now we have an easy way to turn them all on and off. Wonderful. And now we're gonna have to look at some code. Import, edit, pause. What are we doing here? We got the volatile stack, oxygen analyzer, and the mixture for our devices. They will have alias, sterling power is D3. Steel ring. So sterling power will be D3. Now, when do we want sterling power to turn off? Well, we are looking at here lays an alias for sterling input analyzer into D4. Wonderful. So from our sterling input analyzer, we measure temperature. If temperature is below 250 degrees Celsius, we turn off the power. No. We go to 200 degrees Celsius. So if the temperature goes to or below 200 degrees Celsius, Stirling engines turn off. If that is the case, then we check the Stirling input analyzer's contents, where we double check whether or not we have water still in the pipes. If there's still water in the pipes, it should be liquefying, as we saw there. It should no longer be steam, which means we can then start. We wait for that to happen. With no longer any steam left, we activate purge. Alias Stirling output pump. Why do I keep on why can't I write Stirling? What kind of monstrous poop nugget am I? There we go. And the Stirling output pump will be D5. And Stirling power, let's do that. Stirling power switch, D3. Input analyzer, D4. Output pump, D5. Now, can we can we get everything there? I think this might work better. If we then I think we'll have to remove the one-way valve, even though it was doing its work. But this way we'll have the ongoing cycling inside the pipe, and we have the PID system maintaining the pressure. So we'll then have one last. No, that's all 6. Shit, so that won't work. Well. Now, one of the problems here is we have 3 things. As an input here. Because you see, we could... I was kind of thinking about we can move this guy. Or script. Into the... thing. The H2 burning machine. So if it would alone deal with, doing its mixing. Now the problem is that device only has 2 device inputs and we need 3. One for the oxygen analyzer, one for the volatile analyzer, which is in this case is the tank, and one for the mixer itself. Now we could, get around that by using batch loads and saves, but that seems like a very dumb way to just get your hands on a single tank. Now we could also have, say, all those named as part of a set, and then we use the device hashes and so forth, and that would also work. Now if we could load in devices by their individual, like, device hashes, that there's the LD one, which there is an ID. It's annoying that because this exists, it's lined over, but it's nowhere in the documentation. So I don't know, does this actually exist? Or is this, deprecated? This exists in the unofficial wiki, but there's a lot of stuff in the unofficial wiki. Because when you look at your configuration tablet at a device, it does give you still its own unique ID. But I think we'll have to do that anyway. If nothing else, we'll just move this chip sort of just as is, without my additions. And we'll move it, because I do believe I have enough housings and I have extra chips in my bucket. Put another housing next to it, place it there, then we'll have all the device inputs we need. But more importantly, we cancel that one. And okay, I'm going to let you hang out there for now. But if I could make use of this one, it'd be heckin' amazing. Now, let's see. We do 5. We do inside here, because we can slap one in there. Whoop. Now, what if we do look at devices D0 and D1? They'd be the analyzers. Yeah, okay. Yeah, okay. Indeed. Boogly boogly. Wrong one.
Hello,
There.
son of Hanu and God of Hanu.
Well, hello there, Oshak. Hope you're doing well. Got a nice, lovely boogie music. Now. Hey, thank you, Oshag. Affiliate anniversary. It's funny because my own Twitch UI kept on saying like, oh, it's on the 7th. So I've been like thinking like, okay, I can still like try to come up with something for tomorrow during the day. But apparently it started already. I guess your affiliate anniversary takes into account the fact that, once we got past 2 o'clock where I am, at least part of the world has already entered the 7th. How many years of affiliation? Well, 1. I started streaming a little over a year ago. I want to say December of 2024 is when I started streaming, and by January I'd made affiliate. A lot of that thanks to the wonderful community of Casual Elephants, because I got, he was one of the inspirations who really made me think about getting into streaming to begin with. And my first streams, being a little old nobody, was like Victorio, and I saw him playing it was Kasheim, and he wanted me to join in. So I joined in on Kasheim, and I got affiliate in 1 month. Around 1 month, yeah. Legendary. Well, thank you, Oshag. But also, as I'm telling the story here, it's thanks to the fact that I got into the Casual Elephant invited me to join his the Kasheim thing, and through that I got a lot more exposure, got some raids and so on, and that's pretty much just pushed me past the requirements, because in it your average viewership was kind of low, and so was the followership that you needed. And yeah, I've also been lucky in the fact that I apparently am the right kind of ADHD here. Like, it's easy enough for me to keep on just talking all day and all night and just expounding on the games. And also it was good time, because that very first Kasheim, I had not played Valheim for a long time, so joining in on the build competition then was super fun, and it allowed me to just sit there and expound on my love for that game. Good times. But I want to say, yeah, it was within, I'd say less than 2 months, because I almost want to say it might have actually still been October. When I did my very first stream, I streamed, like everyone else who begins, a stream for a lot of audiences of zero. Well, no. A lot of audiences of 1 or 2, I think. 1 being myself, and sometimes 2 when the missus remembered to also be watching my streams. But that's where it started from. And then got a little bit of exposure, then Kasheim. When you get to join in on such a wonderful pre-existing community, helps you get a lot more exposure that way, and then you get seen, and then people find you. It's always discoverability that is the biggest hurdle. And now I'm thinking okay, my Twitching is going okay. We slowly but surely things are growing. I'm being discovered here and there, and after this, I funnily enough, hello everyone on YouTube. I noticed you people really like Stationeers. That's good, because so do I. So that part is also growing. Now I just need those followers there as well. I thought you started in December 24. That's why I said 1 month. Yeah. And then that's the thing. That's why I'm wondering. I think it was December 24, but it might have been the end of October. So that's why I want to say it was less than 2 months, but I can't remember if it was within a month. But it was in January then when I finally got all the requirements and officially made affiliate. Because it was in December when the Kasheim started. Yeah. So I got lucky there. Again, congratulations. Well, thank you very much, Oshag. I really do appreciate it. Yeah, it's been a wonderful and fun ride. And hopefully it'll continue for many years to come. Also, one of the reasons why I need to start doing that game dev stuff, because, well, we need to find more ways to make money. Speaking of, hey, if you know someone who, is not following me on YouTube, hey, let them know that I really would appreciate those follows as well. Or subscriptions, as they're called on the YouTube side. We need to get that number to 500. I'm halfway to the required hours watched already. 3,000 in 1 year. We got almost 1,500. Now for this to work, let's see if we can. So if LD and this was there then equivalent SD. So And the mixer is only called, I believe, here. So there's the of an unknown ID. Reference ID, let's write that one down. Come on. There we heckin' go. I want to say that's a B. So it'll be $B 5 3 4 9. Now to see if that is the case, we'll have a look at these others. The BFAF, yeah. So it's a hex, and that's the C's and B's, yeah. Because the reference ID should always be unique. So if you dismantle that thing and rebuild it, the reference ID would be different. Now let's find out if it actually works that way. Because it's overlined, so I'm assuming so this might be deprecated legacy kind of stuff. Oh, now let's see here. So if we then try that, it was a big old dollary dude to begin with. Wait, that's a pound sign. The heck is it? There it was, too close. And a big B. And it was 5 3 4 9. Logic type. Setting. R5. Volatile tank is D0. Analyzer D1. We say okay, we export. I'll put you there. You two can change places. So again, tank 0, analyzer 1. Volatile tank. An oxygen pipe analyzer, volatile tank. So again, 0 was tank, 1 is analyzer. I'll turn you off. Holy shit, it works! Holy shit, it heckin' works. As soon as this goes on, it'll fix the ratio. Okay. Okay. Wonderful. So all of this shit is steered now from here. And we can talk to that chip through the cables directly and or indirectly. Heckin' wonderful. Okay. Ooh, I catch that short, but still confused. But what's the point of this combustion? Oh, yeah. So this combustion is the H2 combustor, which makes fuel source. So volatiles, oxygen from here. The math was amazing because it allowed for the automatic increase and decrease of the gas mixer to always keep the ratio correct for the oxygen and volatiles, even though they're different temperatures and different pressures, so they're different expansions, to get the correct mole amount in here to have the perfect fuel mixture. And that was the magic. like one of those things that I don't really understand until someone tell me, yeah, sorry. That short was just, I wanted to sort of like show, the sort of, it was a gratitude and excitement I can feel from the help I can sometimes get from people. So now this thing can control its own fuel mixture from here. And I was wondering if the device saving into things using their direct reference ID was actually something we could do, on account of there not being any real in-game documentation, and when you write it, it like line crosses itself over. But we got it to work. So that's amazing. Which means we can now remove it from this guy's code. So we'll just have to have a separate logic here that essentially turns this thing on or off, and this thing on or off. Now, the fuel gas mixture doesn't have to be entirely extremely perfect at all times, so we could even have possibly an in-out logic chip which mirrors this one's on state into that one's on state, if I've understood how they work. Which might be wrong. But he only has an in, has no out. Fine. I guess this is a way to separate logic networks, and this thing just copies a value from somewhere, keeps it in there. Slot reader, batch reader, reagent reader, batch slot reader, logic writer, switch. Heckin' what? So we choose out and which variable. Okay, so okay, yeah. We choose who are you writing to and into what. So, part of our logical power switch. And then the logic reader, writer, batch reader, writer, logic mirror. The mirror seems not very useful for us right now. We would need 2 chips, pretty much. One reader to read this one's state, and one writer to write it in that one's state. Wait. Wait, no. That wouldn't work either. I'm thinking, what if I just turn this thing on and... Because if you turn this thing off, then I'm pretty sure the code is no longer running, so I can't have that code there detect, like, if this thing is on, turn that on, if it's not, turn it off, kind of thing. So that won't work. But we can now essentially clear that thing completely. So now for D0, no, sorry. We alias our Sterling input pump. Sterling output pump. Sterling power switch. We got D0. We got D1, and we have D2. Now what else did we need to do here when we needed to have the input analyzer or analyzer here for D3. I mean, technically, I guess we don't even need the freaking whole everything Sterling, but we'll get there. So the input pump determines if it's on or off. The pit is controlling it at all times. We don't need to worry about that. Except for its on-off state. It's reading also the analyzer for its pressure. So that's also A-okay. Then we have, from here, with the analyzer, we're reading the temperature, the other shenanigans. Yeah, we can have, and I put in the one-way valve not too long ago, and now we're gonna have to remove it again. That's okay. 2 condensation valves is, well, 2 condensation valves is more than 1. Let's hope they work together or something. I don't think it'll be a problem. Because then we can, because if the input pump is closed, output pump is on. Now from the analyzer we will know whether or not the pipe system is, what it needs to be doing, needs doing. Now, can we fit? And we need 2 more. We have the input tank. Also, these are devices. I want them to be capitalized. And I don't care about the output tank. I don't know. But we could then have the H2 combustor. No, but then when the H2 combustor also needs to deal with its own tank. I mean, the pump. So maybe it's best if we just had everything in 2 separate systems. Yeah, it might be for the best that way. What you got in now? Hey there, Balin. Oh, I'm automating more of this stuff because I put the fuel mixing script here now into a chip that is directly the H2 combustor. Now I'm realizing, well, we can't really have that now, can we? Because I just want a sort of purge system, because once the gases get cool enough in the loop of the input-output, I want the input pump from the hot steam to stop. And I want to double check to make sure if water is still going through condensation, wait for that to be finished. And once that's done, then the output pump sucks out the gases, voids the entire pipe system, and shuts down, and then the input pump can go back on. And also, once we have reached the appropriate temperature, the Stirling power switch gets flipped as well. And then I was thinking, could I control the combustor from here as well? But we don't have enough device ports. And currently the combustor's chip is in a in the combustor itself. Only has 2 inputs. But I have more housings, so I'm going to have probably slap down housing on that end. And that way the combustor will be monitoring the input tank's pressure. If the input tank's pressure is below a pressure point, it will start producing steam. And so on. Remember, you can device IDs? Yes, I know. And that is how I got the H2 combustor to work, because it only has the two inputs. And then I just checked the device ID on the mixer, and then I got all that to work. I was like, awesome. But now, for this to work, I would then have to have multiple device IDs on a single chip. And I was thinking, you know what, I might I'm not, it's not unheard of for me to suddenly start like ripping out pieces and replacing them and just organizing stuff. So maybe it'll be safer and also like neater, so like logically to have these things in their separate compartmentalized pieces rather than one giant mega code. Unless, of course, is a giant mega code more computer memory efficient than multiple small ones? I don't know. But if we let the input... So we can... Do we care about the input tank at all? In this situation. I mean, I guess we could just check if the input tank can't... If it's empty. You know. Don't even try. That would make sense. If there's nothing in the input tank, you know, sleep for 3 seconds, don't do anything. Similar to if I put down a separate compartmentalized code there on the volatiles, the H2 combustor side, it is then also looking at its volatile tank. If the volatile tank is empty, you know, don't even try. You know, stop causing a mess. So you're trying to control Stirling gens and H2 combustor and gas mixer at the same time. No, I was wondering if that is necessary, or if I should have 2 separate chips. And I think 2 separate chips is better, because the gas mixer and H2 combustor can be on one chip. Because if I do put a housing there, we got our 6 device connections, and that would be enough to, you know, do all of that. Because then it can control the H2 combustor, it can control the turbo pump that is sucking out its output. And it can do the gas mixing and, you know, monitor all of that. So I think for this chip, we're just going to look at the input tank to know whether or not our Stirling engines should be on, and whether or not the input or output pumps should be on, and that kind of stuff. I think that'll be easy enough here. So those will be our current aliases. So if we just look at this thing, so if I... Let's see, we'll click on confirm so I can like walk you through the load. There we go. So the chip would be checking, is there gas in here? If yes, then you can activate this pump. And then this pump is being actively controlled by the PID. And we have a batch writer, because I'm assuming a batch writer logic block might be more logic, might be less memory stressful than code. I don't know if there would be, but I'm hoping and assuming there might be. So this batch writer is writing the on state of those, and it is currently reading the state of this switch. There we go. So those are done. And the idea is that once the temperature gets to, I guess, 480 Kelvin. Seems like a decent enough point to stop. Or 470. So 470 Kelvin. Once you reach that point, you know, that's gonna the code is gonna flip this switch, which makes that one turn these off. Then we wait until there is no water or steam left inside the pipes. When there's no water or steam left inside the pipes, this one turns on, sucks out all the gases from the pipes. Now we're gonna have to remove this thing, but that's okay. And put all the steam in here. Then we'll figure out what the heck to do with this thing eventually. But for now, that's what it's doing. And once this one detects that the pipes are empty, we exit this loop, turning this pump off. And this pump goes back on again, if there's something inside here. Thank you, the Inker, for that follow. I really do appreciate it, and I hope you're having a wonderful day, my friend. And that is why, and that is how that system works. That is what this chip should be doing. And then separately, I'm going to take this chip out from here we're gonna add a chip housing here, and it will then be controlling the combustor, the gas mixing, the whether or not we have volatiles, this pump, and also monitoring the tank. So if the tank pressure is below target and we have volatiles, activate mixer and burner, combustor, and keep this pump going. Whenever this one gets turned off, you know, because of we reach pressure or we run out of volatiles, that is when we sleep for a few seconds. Wait, no, this thing had a pressure meter, hopefully on the output. We'll double check that when we get there. And then so we either measure the pressure from the output here, if that's possible. If it's not, then we just have a sleep where this pump remains active for an X amount of time to make sure we have a vacuum in this pipe. Why do you have a turbo on the output of the H2? Oh, because previously it wasn't there. The H2 combustor leaks temperature. So once it's not really needed. These pipes started having like liquid freezing inside because this thing leaks temperature. You see, if I turn this thing off, and there's stuff that remains in this pipe, you know, then they started like turning liquid. That's what I had to like give me last time I was testing. It had to quickly turn it back on, so we got the heat back in there, and then I had to slap in like a pump or this pump here to like just suck a vacuum out there, so these don't burst when this thing turns off. So technically, for like visual clarity, we could move this pump from here to here, though it doesn't really matter. But the point is, wait, okay, no, it does matter, because if we put this pump here, then we don't even need to look at the pressure there. Now it'll be fine.
Power low.
Personally, I'd use a drain. Have some loss, but not much. Yeah, I'm thinking about it. So you need a liquid drain and a one-way valve. Because otherwise, the steam tank that we're putting it into to be the sort of temporary holder would also get heckin' drained when should the pipe burst. Because it will keep on leaking.
Hunger caution.
Magic, mega drink magic. Well, the plants are doing okay, so the code here has begun working again. I really need to rewrite this one, but I'm not going to do it yet because before we get into the whole Larry magic, I'm going to make a better harvest system here just because I wanna. Because I can, pretty much.
Power low.
We unleash our mouth farts on the world, and we do that. We're not producing enough power, and that's okay. We're in the suits, we got our vitals on, we have enough oxygen to hang out for a little while. Leftover volume will be too low of pressure to condense out. Oh, there we go. Power soul fucked again. Well, I've been ignoring a lot of coal. Wondering, like, where is all that power going? And then I remembered I have a large amount of freaking electrical centrifuges that are just on all the time because I'm a moron. They have a code controlling them. We just need to make it better to detect, like, do you have anything inside you? If not, just please turn off. But first, we're gonna muck around with this thing. Yeah, now the problem is, of course, because if we have a liquid drained here, for example, so stuff turns liquid, this one will still keep on leaking heat. So we need then to have a one-way valve as well. So that could be a way to do it. So we have a liquid valve, lets the liquid come out, one-way valve to make sure that shit doesn't freeze, because then it would eventually, you know, because it's one enclosed system. So that's why the pump was there. But I guess that could work. One liquid valve, one-way valve, one-way valve, one-way valve. Come on, I can't say those words. So the one condensation. No, wait, no, there's the passive liquid drain. That's what we need. And the one-way valve. Yeah, the passive would have allowed the liquids to bugger off from in here. With the one-way valve and liquid drain, they will be lost but less power cost. Yeah, that is very true. That's very true. That is what I'm realizing here. Alright. Once again, Baylane Elamain has me convinced. For a large part, I will admit, because I completely forgot that the passive liquid drains were a thing. I've been adding so many of these manual freaking condensation valves. Now, hopefully we'll have a little bit more iron to smelt, because I'm pretty sure we need one of these. There's a new, Oh, I have these. Nice. Turbo pump's cost is 200 to 1000 watts per setting, depending. So a passive one moves liquids from a pipe network to the world atmosphere, which will be a-okay. And especially if you have that for the tiny piece of piping we have between the... God damn, I love these tunes. We have one liquid drain, there we go. And also, I will admit, another thing why I really like these tunes is because I like mucking around with the music blocks in this game. And I would love to figure out like the coding way to then turn these blocks on and off. Because I'm recognizing so many bits of like, okay, these four tunes, I can make this because we're just repeating from like track to track to track. We have an underlying like beat that keeps on going, and then we're so we can like jump between those. And that will be a really fun challenge.
Incoming.
Hey!
Incoming. Storm. Incoming. Storm.
Oh.
Incoming. Storm. Incoming.
That's okay.
Storm. Incoming.
I suspect
Storm. Incoming.
there might be a storm soon.
Storm. Incoming. Storm. Incoming. Storm. Incoming. Storm. Incoming.
You said alarming soon. I did, Space Andrew Gaming.
Incoming.
It took me a long while to figure out how to do it, and I got frustrated, and people got frustrated trying to help me because I had a very deep misunderstanding of how exactly the transmitter worked.
Storm. Incoming. Storm. Incoming.
And I felt like a
Storm. Incoming.
dumbass after figuring it out.
Incoming. Storm. Incoming. Storm. Incoming.
That's interesting.
Incoming. Storm. Incoming. Storm. Incoming. Storm. Incoming. Storm. Incoming. Storm. Incoming.
I believe there's a storm incoming.
Storm. Incoming.
A mild suspicion.
Storm incoming. Storm.
I'll put you in my pocket.
incoming. Storm incoming.
Did these signal to klaxon suit or both? Both! Balin. Here it is. This is the entire thing. We just jumped start to play storm incoming. Transmitter sound alert. Klaxon sound alert. Sleep. Turn them both off. Jump back to start. We go to start. We yield. We station in mode. Weather mode. Station mode. Time to storm. Weather station next weather event. Now there was SDDB setting time to storm. XR klaxon playing station mode, old station mode. So station mode equals mode. Klaxon playing branch equal klaxon playing 1. Oh, that's why. I was wondering because this thing should be doing a thing, but it wasn't. And that's why. I want you to do it, actually do it in both states, and we confirm. We pushed the wrong button. Now we're sad, and that's okay. Because I wanted it to detect a change in state. Alright, seems to have mostly worked. Now, there we have, and setting 0, setting 0. Why is setting 0 even though setting should be saving the time to storm? Next weather event time remains 0. Huh. I think I misunderstood how that thing works. Oh, that's okay. We're gonna hang out here at base anyway, so once the storm comes, you know, the storm hits, it hits. And, you know, the good thing is, once the storm eventually hits, we will be able to, you know, get our batteries or all filled up. What I should do is making more large batteries and slap them out down here. Now, sent to a suit only, then the alarm should happen only once versus repeat. Well, I wanted to set it to the klaxon just because I wanted to see how that would work. And then set it to the suit itself. And yeah, the repeat was happening because, well, I had a loop. Whereas having a... Now it should be only detecting a change between old and new state. Now the old and new state are the same. So funnily enough, actually, I think it would... It'll say storm incoming when it's in storm, when it jumps into mode 2. And then probably when it jumps into mode 1. Or mode 0 as well. We'll find out when we get there. In the meantime, you go in, we import that one. We'll look at what the fuck we were doing. Pause. So it was the Stirling input pump, Stirling output pump, Stirling power switch. Oh, right. Man, that can wait. For a wee bit. Because we got convinced to simplify our systems here. By removing that one. So that is for the liquid drain. One-way valve. 1, 2, 3. 2, 3. I'll be fine. Actually, I won't. Oh yeah, and to remove this one completely. Where's the good old wrenchy? One way. Valve. Passive. Liquid drain. There we go. So now, they'll be okay. Tubing and turbo pump is more than okay to just maintain these pressures we want. Wow. I scripted also a loop and sent back to the tablet. Sent to my tablet. It will activate once and again if I turn the tablet back on. Ah! That sounds handy. Oh, yeah, the tablet can also make noise. I gotta check that one out eventually. Also because I want the easy, turn it off and on again to like switch between the slots, which was active. That's something I want to do as well. Bailey Element on the YouTube side keeps on sharing the deep dark knowledge. Alright, so now yeah, that's fine. Back to this one. Yeah. Okay. There we go. Pause. Alright, so we do the loop and we start thinking about what we do in here. So we'll do is steam. R0. Will be R load into R0 from input tank pressure. Then we define no, we don't need that at all, do we? See, L greater than SGT would be correct, right? Let's typically SGTZ. Right, because 1 if A is greater than 0, otherwise 0. Neat. So if R 0, heckin', if is steam is more than 0, is steam. Now, into steam, we load the pressure of input tank. If it is steam, the pressure is greater than 0. Oh, we got some steam now, don't we? So then we can branch equals 0? No. Was EQZ. Branch to line B if A equals 0. So, branch equals 0. Now, if is steam, That'll be registry, so it's not capitalized. Go back to start. Yield. So also check, you to check. Is there pressure in there? There isn't? Nah. Don't do nothing. In fact, rest, sleep, 5 seconds. Then you go see if it's completely empty, just rest for 5 seconds, then check again. Wonderful. Oh, right. And in case shenanigans. Clear database. Now we go past that one. That means, okay, there's some pressure in there. So what do? We turn the input pump on. No. Then we check if we should turn it on by checking the alias or input pipe state R1, because we'll be checking multiple things with this one, so we'll always know some part of the input pipe state is being checked. Now we load into input pipe state. We load from the input analyzer the temperature. Because the input pipe pressure is being managed, pretty much managed by the PID system, so we don't need to worry about that one here at all. The inbuilt PID chip has so far behaved quite well, so quite enjoying it. Hey, the Knapsor! Nah! Why you scream? What is horrifying him now? Poor Swedish man. We're powered by IKEA's meatballs. Once again. And I can program, but I can't set up my own build environment. That sounds terrible, my friend. Absolutely dreadful. You poor man. Now see here, we're loading the input pipe state, the temperature. Now, we then want to define here now these technically I guess would be min underscore temperature, because this is like, oh wait, no, we can't do all caps, can we? Oh, the underscore was the wrong. I'm gonna do some medieval bunking instead. I hope a good one. I think I missed the whole free chivalry on Epic. It's very tragic. I hope you have a good one, my friend. Mean temperature. Looks like it's working. So let's... Was it 470? So it's 274. Then it's 474 for 200 degrees Celsius. Heckin' perfect. Why you no wanna bunk with us? Because I don't own the bunk game, I think. But one of these days, I'll probably get me a copy. I'll have to check. Do I own it? I don't even know, man. I think I might actually have it on Epic, or like on Epic when it was free there. I'll have to check. But right now, we have to make our Sterling analyzers, analyzing inputs. Have good times. Make these pumps pump. Make them make all the power we need. And we're gonna get all the power we need just in like a few seconds once the storm hits. But we can't always be relying on just storms. And yeah, we need to build just in general more giant mega batteries. Anyway. Well, I probably would not buy it for the standard price on Steam, even if I have played 200 hours. Yeah, the game can be fun, yet still not actually worth the price tag. It's just like, there's really tasty good drinks and foods, but it's not really that tasty to be worth the price tag. Anyway, we have our minimum temperature in Kelvin. We have 200 C in Kelvin. There we go. Now we have... What is bunk all about? Well, Chivalry, it's kind of a, PvP medieval combat game. Can be a lot of fun. Is what it looks like. When you go bonk your enemies using swords and maces and other cool medieval weapons. Now we... So... The BLT. Good old bacon lettuce. Now for BLT, branch to line C if A is less than B. Now if our input pipe state at this point is less than the min temperature, jump into the next loop system that we shall call we'll call it purge. Purge input. If it is not so cold that we want to enter the purge input, well, then we just want the actual input pump to be on. So we save. There we go. Into input pipes, pumps, thing on 1. And jump back to start. We yield again, we check the input tank. I realized, okay, so the rest, seeing as we're resting because the tank is empty, we will probably turn off the pump. So now every time we start the code, we start by turning off the pump. Then we check is there pressure. If there's no pressure, we jump into rest, we wait 5 seconds, make sure the pump remains off. In fact, that'd probably be that way around. So now if we start by making sure the pump is off. We wait for 5 seconds. We go through this. If necessary, we go back to here. Or how about we move all of rest here? So we'll do rest and J, start. Jump start, do the yield. Is there pressure? We see if steam is greater than 0. If it's no, we jump into rest. Can we just... Is this bit here even necessary? Oh well, we'll find out. And then the input pipe side. From the input analyzer, we get the temperature for the input pipe, which is the pipe between the pump and the stirling. And if it is less than the minimum temperature, we jump into purge input, which we'll deal with, we'll write later. Right now we're going into the body if everything is going normally. Then we make sure the pump is on. The pit can keep doing its thing. And do we power switch? Called open equals 1. L2 and the machine is on. If it helps, H2 combustor 2 built-in gas analyzers. Ooh! Thank you, Balin. Sounds pretty cool. I need to have a closer look at all the atmospherics because we can put the chips inside and see what all we could do with that. And that is for then. Now, right now we're just doing this convoluted state of the Stirling engines, the pump being controlled by the PID, the purging of the system, and trying to figure out when we should or should not turn this machine on, which is something we'll have to figure out eventually, I guess. Some other system. Alright, so input button on 1, power switch open 1, start. And the logic will be like pressure output and ratio oxygen input. Cool. Thanks, Balin. Yeah, but right now in this script, the H2 combustor is not evolved at all. We'll be getting to that one next. This is just the Stirling engine and the removal of water from the pipes, and then separating, then removing the cool gas to make space for the hot gas. Now, This would be much simpler if we had them in a series, so that every Stirling engine would be feeding its outputs into the input of the next one, because then we know that the final output will be, cold enough. So we'll be never feeding it back into the input. But because I'm doing it the way I am, that they're in a series, so they all share inputs and outputs, so that the same amount of gas can be. So we should hopefully be producing more power this way. It'll just slower, but also means that we have to have a sort of managing script like this one to make sure that the it doesn't cool itself down too far and so on. If I had in a series, we'd know pretty much that the final output would be cold enough that we can just put in a tank and have a condensation valve, just let the liquids drip out and not really worry about it, and then deal with that. It would be a one-way system rather than this silly looping system I'm making. But, well, and we'll be blamed for many things, but not oversimplifying always. Overcomplicating, yes, that's what I do. Now currently then have we pump goes on, power switch open, equals 1, jump to start. Which means everything is functioning normally. So when do we want the power switch to turn off? When we jump into purge input, the very first thing we do is S into the power switch. 1 becomes 0. The power's turned off. S. Not big S. The input pump is turned off. Followed by L input pipe state input analyzer. And note if you want to use the internal pipe analyzer of H2 at a minimum set the device to mode 0 idle mode. Thanks, Baylin. Now keep that in mind. So input pipe state, input analyzer. What do we got? So ratio steam. Now it says ratio, but I'm assuming we probably get like a freaking percentage back or something. Okay, we'll do first. We'll load in the ratio steam and branch greater than 0. It's pipe state. And you loop to the beginning. So if there is still steam inside the pipe, wait. Yield. If there's no steam inside the pipe, load Come on, you stupid bastard. No. Left control button came off again. Really need to go to that goddamn store and buy a new keyboard. Then we load to the input pipe state, the ratio steam, then we'll check the water. There we go. And we'll do the same one. The more I look at this is the kind of stuff that makes me think about, oh man, I wonder if I could loop this and automate these sort of detection things and so on. Probably could. But this will work. We're not making any giant codes here. Eventually, we probably will. Because, you know, rockets. And I'm assuming there will be all kind of madness involved in those. And that's a then kind of situation. And also because we don't really have a proper like base managing script just yet, and that will also be a whole bunch of scripts. And I was looking forward to doing some like hierarchical chip manage as well with the farming, because that way we could have, like I said, like every housing would be monitoring 6 separate plant freaking devices, hydroponics devices, and saving their states essentially into a binary state inside its own setting, into an integer, and then we can have multiples of these essentially, looking at 6 of these individual planting devices. Then all of those themselves are then controlled by a sort of upper script, which manages them and determines based on their states if something should or should not be done to the device, to the plant in the device, or lack thereof. Should they be planting? Should they be harvesting? And I'm assuming I might be able to use the same logic pushed further, and to see whether or not Larry should do some fertilizing. Now, speaking of, we had the hay thing. We could probably make more of it, and through that we could make. Oh man! Wow, sorry, that's really rude of me. And then we can use hay to decompose that. We can use hay to make charcoal, which we'll need for the water purification system, because, well, I was running a little bit low on water, but we have a large amount of dirty water from all my showering. So we need charcoal for that one. Plus, as far as I know, charcoal can also replace normal coal in furnace recipes. And then if we turn that stuff into compost, we can also get nitrogen and volatiles that way. So that'll be lovely. Okay, but back to the logic here. So the purging input, what do? We first make sure that when we're in this loop, the power switch and input pump are off. First thing we do. Then we check, is there steam inside? If there's steam inside, go back to the loop and wait. And yield, check again. Once there's no more steam in the pipe, then I want you to see if there's water still in the pipe. If there's still water in the pipe, wait for that to fully drain. Once there's no more water in the pipe at all, then we load again into the input pipe state, from the input analyzer. What? I think we're just going to look at straight up pressure. Because those are the only liquids I give a shit about. And once we remove the steam, remove the water, now there's still gas in there. And what do we do? How do we do this? Oh, but by the time we get there, we know for a fact that the water and the steam is gone. So we are now doing the proper purge, which means that we save into output pump on 1. We turn the output pump on. Simple as that. And after the output pump has been turned on, now we check what the pressure is. And we branch if it's greater than 0. It's any pressure. Oh, right, we just do the same thing again. If there still exists pressure in the pipe, jump to the beginning, and we keep on doing this because we keep on checking is there pressure, making sure the pump is on, and then checking should we continue in the code. If we should not be, keep on looping back to the beginning, doing another yield and another check. Once all of that is done, and now the pressure is in fact 0, we save into our output pump on state of 0. We turn the output pump off, and then we jump to start. Because we got here, and we know for a fact at this point there's no steam in there, there's no water in there, and now there's no pressure either. It is completely empty. So we turn off that pump, I jump to the beginning, we check is there steam in our input tank. If there's no steam in the input tank, do a rest, which is just make sure the input pump remains off, wait for 5 seconds and check again. So every 5 seconds we check, do we have actual pressure? And so if we have some pressure in there, that means that the input pipe state, that means we check the temperature of the input pipe state. If the input pipe state is below minimum temperature, we do the purge input. Now we have a problem. Because at this point, this will fail. So we do the purge input. Then we jump in here, we just go through the entire thing, turn on and off again, and jump back to start. So now we have a loop that will never turn the pumps or the power switches on. Which means in the script you're trying to filter out all the water, right? Yes, Balin. Filter out all the water and then also remove any gas that has gotten too cold so that we make room in the pipe for the next sort of batch of gas to cool down, and then we remove that. So essentially we're doing the gas in batches, right? So there's that. Then use temp and ratio water, not pressure. I am using temperature. Temperature jumps into the once the temperature is low enough, we jump into our purge input loop here, which just check is there steam left, because we're waiting for the steam to condense the water and pull out. To force the water out as a liquid, you will need pressure and gas to force the steam into water. Yeah, but the pressure will be at 45, above 40 megapascals no matter what, because of the pit is maintaining that pressure on the input pipe. Now, eventually, it will reach a point where that gas will still be so cold that we can't really put in more heat, and the cooling will keep on happening. And it is at that point, essentially, when this happens, because our logical blocks that we have on the ground there, they're maintaining the pressure, so that's fine out of the hot gas. We don't need to touch those. We're choosing whether our input pump from our giant tank should be on or not, should be allowing more new gas to go in there. Because if we just do the purge, activate the purge essentially, we are not making space for the... Oh, wait. We had the one-way valve there. So I was kind of thinking maybe I should remove, but now what if we do leave it there after all? Because currently we have the liquid removal condensation valves on both the input and output sides of that one-way valve. So if we don't really care to force the water, yeah. I mean, we have the pressure now, the pressure is fine because we've seen it. Just manually pushing the button, it all works. And so to set the stop temp like 200 Celsius exactly. Because if you go below 152, pollutant will condense and contaminate your water with your water supply. Yeah. And that is exactly what we have here, see? 474. 200 degrees Celsius in Kelvin. So that is the minimum temperature. So we're letting the pressure keep on going. We get to 200 degrees Celsius. Then we enter the purge loop, which is checking is there steam or water inside. So while there is still steam, so we're waiting it to condense all into water. Then we check is there still water there. We wait for the condensation valve to drain out. When there's no more water left either, then I check what is the current pressure of the pipe. And I turn the output pump, which is like draining the entire pipe system on. And then we keep on looping at the beginning until this one says there's no more cool gas in there left. Then we turn the output pump off and we jump to the beginning. So now we have a vacuum in that pipe, which means that its temperature will be too low. In other words, yeah, I need to have another check here or figure out to do it somehow differently, where we would check the temperature and the pressure. Because if the pressure is below something, that won't work either, because then if the input tank did not have enough moles, we're also kind of fucked. So I think I'll need another loop essentially here in the end here. Some other task where we put the input pump on and we wait and we sleep for a couple of seconds. Because in those couple of seconds it will not have enough time, even at its maximum output, to burst our pipes. But having even a little bit of gas in there should make the temperature be way above the minimum. So we save our input pump on state as 1. So the input pump is on. We sleep for 2 seconds. We jump back to the start. The only problem will be if our input tank is empty by the time we exit this loop. Because then it will never be able to get in. Because even if we put steam back inside the tank, then this will keep on failing, because this will always be below the minimum temperature, because there's a vacuum here. So I guess we'll have to look at turning the pump on first, because the pump has the pit controlling its output, so it can't go too high anyway. So if we put the input pump on first, the power switch, so we won't turn the Stirling engines on first before we know that it's a good idea. So the input pump goes on. We take the temperature, we go into the purge input. If it's too cold, which most likely will be, we go here, the pump goes off. But there's been a tick or two at that point. Another yield. Would that tick be enough to hopefully have some gas in here? So that between these two, as long as there's gas inside the tank, it will never be a vacuum. It'll only be a vacuum after a purge input loop when the input tank is also completely empty. That should be okay, because there's nothing here that should be able to make the entire system just freaking explode between a couple of yields. We only have a couple of sleeps. One would be here. Oh, that is virtue. Then we don't need this one either. Or this one, I think. We can probably get rid of this one completely, because then the output pump is off. We jump back to the start. We check, is there anything inside the tank? If there's not, we do a rest where we just, don't do all of that. We wait for a few seconds to check again. If there's something inside the tank, the pump goes on. We wait for a single tick. We should hopefully have enough to push some of that into the input pipe. Of course, if the input pipe is already above the pressure, then it won't, because the pit is taking care of that, so it won't break the pipes. It'll just be on. And no matter the pressure, if the temperature is too low, then we enter this loop, or we keep on looping until all our checks, fail essentially. Now an output pump turns off, and we jump back to the start. Yeah. Click on confirm. Slap it on the export. Put you there. Then we'll need this one. Now, input pump D0. Your input. Output. Now, with everything we have here, I think... Yeah, we need to get rid of that one. There we go. So we have output. I don't give a shit about the cool-out tank. That will have its own nonsense eventually. We do. There we go. So. D0 input pump. D1 output pump. Output turbo volume pump. Input turbo volume pump. Then our D2 is the power switch. Stirling on-off switch. D3 was the input analyzer. Stirling input pipe analyzer. Trickle input pipe analyzer. And the last one was input tank, steam input. Steam input tank. Maintain pressure. Temperature is high. I got 2 drain valves because there was that input, that one-way one before. Okay. Looks to be working. This one actually has some water in it. We should deal with that one eventually. Guess I could move one of those here. Because eventually the pressure inside will increase, and especially if we keep on putting in cooler gas, eventually that water will also then turn a liquid. Now they okay. I think I'm gonna rip out this thing. And those two are so close to each other, and as far as I know, the game considers all of these to be magically linked together, rather than have actual liquid flow through. So I think I can just deconstruct this thing. Pressure regulator, volume pump. Digital valve, medium radiator. Man, I need to reorganize this differently. Water and Atmo can hang out there, I guess. There we go. Come on. And there we go. Pipe valve goes there, and we change into this here wrench. And the storm has come. Which means these bastards are most likely producing even more power. Even if they shouldn't. Now let's look inside this cardboard box, inside the space pack, and inside here we have liquid things, and there we go. You're generating 1.76 kilowatts, 75, 1.69, nice, 72, 69. Doing okay. Yeah, so here we see every time the pressure goes below 40 megapascals, which is, you know, eventually will, things cool down and shrink. And water's, you know, stuff turns into steam, steam turns into water, so on and so forth. It is maintaining that 40 megapascals pretty well, actually. Ooh, nice constant volume of 3.5. Now doing this during a storm feels, like I said, a little silly on account of the whole the storm is producing so much more off things. Power through the windmills. Party time. Well, thank you, Neff. I must admit, I was unprepared. Oh, I accidentally turned it off. That was not supposed to happen. Come on. Really enjoy the party music. Oh, then the ad hit. Ah. But it feels weird that it's like an affiliate-versary when I wasn't fully aware. Okay, we're gonna let these be on. I would love to be here to just watch this, but we're gonna lose energy and all the other jazz. But so far, it looks like it's working. The pit is maintaining that 40 megapascal pressure. I was hoping for a 45er, but you know, 40 works. It was fun seeing it flick this switch. Batch rider is following that one. Now if we walk away, it'll either work or there will be explosions. But it's going down so slowly, so it's not really worth my time to hang out here either. Now we're making a lot more power. Well, I guess I could at least use this chance to... Man, I just want to see it cool down. It's pretty neat how precisely it remains that 40 megapascal. Considering earlier when I was trying it, it kept on like jumping up and down, but I guess like this it gets to be on for long enough. Now it has that very like steady flow. Considering it's only doing 3.5 liters to remain here, maybe we should consider changing this one out into a volume pump. Turbo pump might not be strictly necessary here. It's more than handy for that one, because it'll make the whole purge process just be faster, I guess. But you know, then again, volume pumps on both of these might be more than enough. Well, while we wait for this thing to either, you know, work out or explode, how about we have a closer look-see here? Now for this one, now it contains a lot of other shit. And I do believe at around 150 degrees Celsius, pollutants turn liquid. I'm just wondering what all we could do with that. Well, one of the things we could do is like Bailey and Element on this side. I pointed out if we had a liquid drain attached to a gas pipe, and we cooled that gas pipe down to 100 degrees Celsius. We could have the pollutants leak out, turn to ice, and drop on out of there. I'm just wondering, like, could we, because we can't really have that then, wait, can we? Yeah, so it turns into liquid, the liquid drain, it drops out of the liquid drain into space. We can have that space be exposed to the external atmosphere, meaning that the liquid would freeze to ice. And the problem is, I don't think we have that much like liquid CO2 or the ability to make it. So what if we use like a pipe radiator? I'm a large radiators, but I think they're a bit too efficient. So what if I have a very small, just a pipe radiator that would allow for this system? Or, silly me, what if, first of all, remove those cables. A closer look here again. We are at 374. We're getting there. We're getting there. Nice and steady. Flowing steady. The nitrogen filter is almost out, but so is this silly little oxygen tank, so that's fine. I think we're gonna be with the next tank. We'll put it into our pocket because it should be like pure oxygen. Then in our pocket we exchange the places. Then we take this old tank out here and we'll just vent it. And hopefully that nitrogen will just back off. That would be lovely. Now, if we add a Weaver, and we open this one and we look at here. Look at our space pack and look at our pump. We have the volume pump. Now, purge valve allows with removal of pressure and gas and evaporate liquid from a liquid pipe. Similar in function to a back pressure regulator. The purge valve moves gas from the input liquid pipe to the output gas pipe, aiming to keep the pressure of input at the target setting. Base power usage is 100 wattage. Now, it's pressure regulator. Excellent, muy caliente. Now this one, if nothing else, we can use it now. That's a pump. Surprisingly, no warnings yet. Digital valve. Turbo pump. Gas mixer. Volume pump. There we go, pressure. I could have sworn, yeah, I saw that pressure regulator somewhere. Then we have back pressure, pressure and valve. And the purge valve.
Hunger caution.
You want to convert the contents of that liquid tank into ice? Well, Bailey, no. I was trying to think if I can remove the remove the liquids from there. The gases that we don't want in there from there. Well, there's temperatures very slowly going down. Because the steam starts turning into water, the water starts pouring out, so they're doing it in the A-OK here. Because there's pollutants and shit here. And I was thinking if I just used a pressure valve currently to just suck stuff out back into this tank system. There we go. Okay, we only have 5 bits of that kind of pipe. Which means we have to do a little wrenchy magic. Could you fucking... Thank you. How much stuff is this in the tank? 57 liters right now. What the frick am I doing here? Right. This. Like the exact number, it has 84.5 liters of water at 261 degrees Celsius and increasing. And if we end up sucking out, turning that water into steam doing this, well, then that's what happens. Because I want to know. We must explore the options. There we go. We must first use an expansion valve to dump its content to a freezer room. Let's move liquids from a liquid pipe into a gas pipe. Only allows liquids to pass in one direction. Typically, this is done to allow the liquid to evaporate into a gas as part of the air conditioning loop. Neat. Hey there, puppy. Thank you very much for that lurk, and I hope you're having a most wonderful day, my friend. And bird farts are slow, or yeah. No, I see this. I see what you're saying, but right now I'm just kind of like just fucking around as well. And I kind of want to see what it does. And first of all, how are you doing? You are 361 degrees Celsius. It doesn't really go much below that, but I guess at this point is when the steam starts turning in the water. The water keeps on being removed, so we are constantly... Yeah, the input of hot gas keeps on increasing to maintain this. And that is actually going down pretty fast, so we're gonna end up in an interesting situation soonish. Shit. Okay. Let's go run and see if we can be fast enough to get a new oxygen tank into us. before our Stirling engines explode, because I realized there's another problem in my code. It is not. What is the problem? What happens if the input tank is emptied out before we enter a purge loop?
Low pressure. Oxygen critical. Pressure critical.
Ooh, we're properly emptied too. So then we can just do that instead. Nice. Might as well change batteries too, and hopefully we'll make it back before anything explodes. And a portables connector has both gas and liquid connection, so you can use the turbo pump to pull the gases out. Oh. We'll have to look at that. You are trying to maintain the pressure. We can no longer maintain the pressure because we're running out of stuff to pump in there. Now the problem is let's pause. Alright. And connect the liquid network to portable liquid tank mounted. The portable is connected to both gas and liquid, so I can use turbo to pull the gases out. Oh. Well, Bailey and Alamein, that is a wild. That's some crazy shit. I never considered that. But yeah, you're right. The portables connector has the liquid and gas. So, but that is cheesy as hell. Because there's all the engineering, like, condensation, evaporation, so on. But a portables tank, it's magic. You just suck out gas. How? Don't ask questions. Gas comes out. Now, of course, I might make use of that cheese eventually, you know. But right now, we're going to make this in the difficult and awkward way, if possible. So, time has been paused. Let's walk through this stuff again. Yeah, first we yield. Is there steam in the input tank? If answer is no, we rest. Which means if the input tank runs out, then the rest of this just doesn't happen. Which means there's some far better system here. You can see I'm dumb. We can skip this entire rest thing, which felt clever at the time, just not have this thing looping too much and too often. Where we save into the input pumps its on state, which would be is steam. Because here we greater than 0. If steam is greater than 0, it's a 1. If there's no pressure, it's empty, then it's a 0. So input pump is on if there's pressure inside the tank, otherwise it'll be off. And we yield and we check the temperature of our input pipe, which is for the actual engine. And then we do check the purge inputs and whatnot. Power switch open 1. Now, let's walk through this. Temperature is too low. We jump into the purge loop. We turn off the power and the input pump. We keep on looping this entire thing. Almost done with everything. We purge it. There's no input. There's no pressure. output pump has been turned on and eventually had all been purged. So now the output pump shall be turned off. We jump back to beginning. So now we have nothing in our output inside the input pipe after the input pump, and the power for the machine is off. We jump in here. If there is pressure in the tank, the pump is on. If there's no pressure in the tank, the pump is off. We yield. We load in the pressure. The temperature is vacuum. We do purge input. We turn everything off. We do all this interpret, then on and off again quickly, which is nothing but it is an on and off again for the machine, which is less than ideal. Right. But should this one also be? We turn the power on. If there is fuel to be pumped in, the input tank pressure is empty, so we don't turn our Stirlings on. Seems sensible enough to me. The power switch is steam. This way we can make sure that if there's no input gas, no, see, that's wrong. It's bad. Because what if, we still need to cool that shit off, eh? So we do want to turn it on until we have to purge. Make sure the power switch is off, input is off. I mean, I guess we could just add another test here. What if we load in the pressure? At the beginning here, and if the pressure is 0 because they're gonna vacuum, then jump back to start. Ignore all of this bullshit. Well, feels a little awkward, but why not? And then we branch equal 0 input pipe state, and you jump to start. So temperature is too low. We could even put it here actually. So first we check the pressure. So start. Yield. Is there pressure inside our tank? If yes, if steam becomes 1. If no, if steam becomes 0. Then our input pump's active state is based on that one. If there is gas to pump in, go active. If there is nothing, then turn off. We yield, we check for input state pipes. Pipe analyzer. Is there pressure in the actual pipe heading into the no, actually it's better to have it here because then this will turn shit off. Yeah, it's better this way. We check our temperature. Our temperature will most likely be below 200 degrees Celsius, considering we are, you know, there's nothing in there. Which means we jump into purge. Which means turn everything off. Off. And then we'll check if there's actually anything in there. If there's nothing, we then go back to start and we go through everything. So only if there's actually something in the input pipe to purge do we do the rest of the purge logic here. Otherwise we jump back out. Just have those here to make sure that while we're doing this, nothing is left on to, you know, could potentially cause a havoc. And we go from here. So the pump goes on. There is something inside there, and the temperature is greater than minimum temperature. Then we make sure the power switch, the Stirlings are on. Confirm. Or click on the exporting.
Hydration critical.
245. See, it keeps on trying to desperately pump more and more shit. But alas, there's so little, so small amounts of moles. No matter how hard you pump, you just can't make it. But it's gonna still keep on doing it. Now with this current code, we're gonna run out of gas before we run out of temp. Already all of that shit is turning in the water, steam into water, so that's a-okay. We almost got almost 100 liters here already. Isn't that fucking lovely? So, there we go.
Hunger critical.
Yeah. Okay, well, that is pretty fucking slow. Well, there's only water in there, no steam. Very slowly purging the gas in here. Very, very slowly. Okay, well, that's gonna take forever. Okay, your temp is incorrect logic type line 31. Oh, butt nuggets. There we go. Incorrect logic on line 31. Open the power switch. Pressure got a little high there for a tiny sec. It's fine. Well, there's no water in here. Temp got a little low. So everything there is going correctly. Shit's being pumped in here. Small amount of volatiles is burning. That's okay. Okay, we're about to start taking health damage soon, but that's okay. Need to see if this thing actually works. That's weird. And oh, because he pumped in this shit. And like cooled off immediately? Is that what happened? Okay. Not long left. Come on. Four, 3, 2, 1. Don't worry about the die. Okay. We pause. When we enter, when we exit the purge, jump to start. Use their Steam. We save into here. Do that instead. There we go. Do that and hope for the best. It's not like there's too much left in here, so it's fine. But yeah, let's go not die. %. Doing okay. Wrong room. You still have small bits of bread left. Oh, we're unhappy because of all the health damage from the whole, starving and, bad hygiene. All the good stuff. Get naked. There. We instantly drank our hydration all the way up to 174% with the magic of alt clicking. We consume the bread. Like no one's consumed it before. Now quick drinky pinky. And unleash our mouth farts upon the plants. Change the battery. Harvest be harvin'. Farmers be farming. We have here 131 liters of filthy water. Batteries are charging. Oh, right, yeah, that's why. I was like, why were you charging of all the batteries? And oh, yeah, because I changed it out, didn't I? Ricky, thank you. Ouch. There we go. Our filthy water container. That's one thing. And we need also then, yeah, some logic to monitor our batteries and then send that somewhere and have a large, giant, big old screen to show us how much power do we have. Yeah. While you're waiting, they're desperately trying because the pressure is so non-existent. That was weird. Why were you on at the same time? Okay. Let's have a closer look again. Now, what the frick the frack happened here? Okay. Is steam. Input pump on. Sleep. And we'll check all this shit. Go through here. We've gone through the purge. Output pump. Oh, that's why. I wonder if you can shower with hot water. That could be neat to find out. 200 degrees. A mild boiling. Really, exfoliates the skin. Burns that filth right out of you. Or drink hot water. I've heard you can. I suppose composter can take super hot water too. I mean, I think my dude has been drinking rather warm water, yes. Also showering with it. I guess as long as it's liquid, it can be used for drinking and showering. If input pipe state is greater than 0, we jump back here. So how about after we do that one, we do input pipe state. No, input pipe state. Now, input pipe state is greater than 0, which means there is pressure. Then, output pump takes the input pipe state. If pressure has reached 0, input pipe state is 0. Output pump is off. If it's greater than 0, we jump back to purge input, keep on doing this. Then we turn it off, We keep going. So we do that. We remove this one. And now this will be removed. We confirm. Export. So now when you turn off, now you should actually turn off again. Shouldn't be spending too much time with nonsense. There's very, very small pressure left. It's desperately being pumped here. Interestingly enough, you're not on. These guys are like trying to do something. They're 0.01 moles. Generating 0. What's happening to these gases? Like, where are they going? Are they being drained as liquids into here? Can't really see with all that happening. Well, megapascals. And this one is still theoretically purging out gas. Pressure of 9.5, pressure of... Okay, so it's having difficulty because the exit pressure is so much higher. That's my guess, at least. Okay. Oh, would you look at that? You actually turned off. Pressure, none. Did the gases like fully evaporate or all like instantly turn liquid or what? What happened there? I don't think anything has burst. Oh well. Whee! Now the idea was to then remove the chip from there, put down another chippy whippy here. Let's see. And because the purge valve is actually being heckin' slow, I can only assume it is on account of the whole pressure difference. So if we had a pumping this into, say, the atmosphere itself, you might be doing a better job of it. So I slapped down one of these. Seeing as it has its liquid and gas inputs connections, we get to, link it to the system our liquid tank is part of. And then with a gas pump, just remove the gases. Which feels very cheesy. But I guess it would work. Hey, whoop. Alright, okay. Let's have another look-see here then. We open this we open that one. There you go, grab those. And we open this one, and here we should have... I see housing. Hey, we still have one here. I'll put you there, so... you're slightly, hopefully slightly safer. Connect those. And I know plants can't take really hot water, and some plants need warm 20 Celsius water, like 20 to 40. Ooh, good to know. Thank you for letting me know, Balin Alamein, over on the YouTube side. Now we've connected this one. I wanted to do the mixing, so I need to look at this one, that one, and that one. That is 3. Include this one, that is 4, and that one would be 5. I think that one, that might be enough. Combustor, the fuel gas mixer, oxygen pipe analyzer, volatiles tank, and steam input. A fuel gas mixer. H2 combustor. Inputs. Oxygen pipe analyzer. What one I want to be the volatiles. And then it was the, what do you call it? Steam? Steam input. Okay. Ah, wait. No need to do that. Yoink. Okay. Number 1, mixer. Number 2, H2. Mixer. To combustor gets D1. O2 is oxygen. Come on. Can't write for shit here. There we go. So D2 with oxygen now, and the number 3 was that one, and the alias, like in steam tank, D4. Yeah. There we go. So now everything works fine. We'll look at the volatiles, temperatures, and whatnot. We don't really give a shit about the pressure here, so yeah. And yeah. Now I'm back to start. There we go. And you save it in the setting. Now, when do we even enter this one? So this one means we need to add stuff in the beginning here. Before we look at any of that shit, what we do is alias steam pressure into R2. Then we alias now we ain't good. R3, and we do actually alias Alkias, alias volatiles pressure into R2. Now, oxy pressure we don't give a shit about because that is just the atmosphere. It'll always be okay. Volatile pressure, so that we know that in case we're out of volatiles, they'll stop trying to mix fuel, okay? Also, pause the game. Also, I do need to shower. He's being all nasty. We can get rid of those. Original math happens here. There we go. At the very beginning, we load into volatile pressure from volatiles tank pressure. Then we load from into steam pressure from steam tank pressure. Now, there we go. That's my mistake. And then if also yield. Now branch, if it equals 0, voila pressure to start. So we take, would you say, do we have any? We got anything in our volatile tank? We could even do a little bit of a rest period here, right? You don't even take it all the time. The volatile tank pressure is equals 0. Here we could have a rest, sleep, 1 second. And then it's fine because we like turn it on, it jumps there. Now if volatile pressure equals 0, we'll be looping through here. Gotta go, catch you later. Hey, thank you again for hanging out again, Bailey and Ellamain. I hope you have a wonderful day, whatever you do. And I'll see you next time. On the next episode of Dragon Ball Z, as they say. No. The thing is, we are getting the pressure, which also probably at the beginning of the loop make sure everything's off. So we enter the rest. We do H2 combustor. We save into H2 combustor into its on state as 0. We save into mixer into its on state as 0. So if we are looping through rest, we're making sure we're not doing anything either. We don't like leave a machine on because of because we're not dealing with the rest of the logic. We're just looking at H2 combustor is off, mixer is off. We sleep for 1 second. We enter the main loop where we have a yield. We check the pressure of volatiles. And if there are no volatiles, jump back into rest to make sure we turn everything off. And the idea is here because if we go, we are making fuel, so the mixer is on, the combustor is on, and then we run out of volatiles. Well, we want to make sure we actually turn that shit off as well, now don't we? That is why inside the rest we're turning that stuff off. And then we're waiting for, more volatiles to appear magically from somewhere. Now if we have volatiles, then we'll check, well, what does steam pressure look like? It means we add here and define for Steam Max, which is 50,000. No, 500,000. That would explode everything. But 50,000. So 50 megapascals is what we try to have in the steam tank. Oh, and when you turn on, do this, we do the defines, and we do a clear of the database every time you turn on. We should probably have a separate system then for controlling these, which would be looking at the housings themselves, so that if necessary, turn off fucking everything. And when necessary, turn on everything, like we're doing. But we need more power, we need more water, and so on and so forth. Now, the amount of water this produces is some, as we saw, will be that small tank we made can hold 6,000 liters. We got like barely 100 with everything we made, so I don't think we're in too big of a risk here just yet. Now, after this, get the steam, and if branch, if it's greater than, if steam pressure is greater than the steam max, jump into rest. Double check, I don't have those going around, so BGT. Branch to line C if A is greater than B. So if our steam tank has a pressure greater than 50,000 pascals, so 50 megapascals, and jump back to rest, turn off the H2 combustor, turn off the mixer, sleep for a second, jump into yield, keep doing this. But if we have volatiles, our steam tank pressure is below the maximum, then we do a yield, and then we start going through the mathematics. Yeah? Oh. For some reason I was expecting there to be trouble. Oh, did I do that without turning off my... I think I might have... Oh right, I did, didn't I? Now we export. I'm going to slap you in there. Cool. There we go. Laptop is error unknown at line 48. S mixer setting R55. Well, there's no R55 now, is there? So we confirm. Turn you off. Put you in. Multi-click on the export. Well, I guess it's working. Mostly. Because you know what, so we have a safety system that'll turn everything off when necessary, but you know what we're not doing? Turning anything on. Now we're turning anything off. So I guess if we make it past this point, well, we're in business. Which I guess means we save into the H2 combustor. Fix the spelling. Into its on state, we save a 1. Same as our mixer. We confirm. We stop. Pressure to 49. Okay, the fun thing is, of course, currently, yeah, this thing will just keep doing its darndest. Very slowly but surely get to the target pressure. Now it's getting there, which means then eventually this output will exceed the needs of this pipe. But again, that's, eventually. Ooh, look at that, then the pressure keeps on dropping though. So I wonder what will happen first. Reaches the target temperature on the first purge loop. I kinda wanna leave this all on and just run away and hope for the heckin' best. Process input 1 mole. Now this pipe contains perfect fuel, an adequate amount. Burning that shit. Small amounts of water are actually being lost here thanks to this guy. But as long as they make it to this side, it'll be okay. We got like 0.46, 0.7. Hmm. 0.46 milliliters. Yeah, see, there's water that is evaporating and freezing at the same time in this air around us. So, is there a chance of getting like pure water ice eventually? Probably if we did build a room around this bastard. And I'm wondering if the using a pump would have been actually better in the end. Because yeah, it is passively, it is like it's continuously letting all the liquid in there just, evaporate. I think if we had a condensation valve here that came to the sign and a bit of liquid pipe, then we could have the purge valve here. These beads, of course, we need a detection system for is there gas here? If there is, purge it back in here. Pressure is increasing very slowly, but the temperature is going down. So it's an interesting state, this one. You know, it's very neat in many ways. And here we have 8.53 kilomoles left. .455 milliliters of water being condensed into gas. Now there's not any water here anymore, which is interesting. So whenever this thing did leak is gone. And 300 kilopascals of pressure. Nice. But it's slowly but surely working towards it. Oh, we're so unhygienic. Our dude is having the sad. Now the temperature here keeps on. Being sad. You are at 274 megapascals. I don't even know if there's any noticeable loss. Heckin' heck. Do I really have to do it? I guess I do. We'll have to do the... Well, first we do the shower. Which makes sense, you know? We have become a dirty, dirty boy. And then we'll look about doing the portable tank cheese. But I should do anyway. For a certain little something something. The... Being, trying to make liquid nitrogen. Should be sort of relatively easy to do. In here. On Europa, because it is so heckin' cold. Because the last liquid nitrogen we also did with some temperature changing back and forth, and it was all, well, a bit of a mess. It worked out in the end, but it took a while. But you can do some magic with the portables. Which would be interesting to try out. Let's change that battery. Now we need to go mining for materials. We need constantin, iron, whatnot. Because we need those CO2 filters. Not now, then, well, eventually. So infinite oxygen is very handy. Bom, 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 bom. Wow, wow, wow. And because between storms we kept on losing everything, so letting this thing actually run probably is fine. I'm gonna fuck with it. And try to make it cool down faster, pretty much. Because now it's heating up instead of cooling down because of what I've done. Oh no! Such silly mistakes. Now we ease the pressure, possibly lower the temp. Well, not that much lower the temp, but at least increase the pressure. It'll also allow us to get rid of some of this steam inside here. And we'll stop there. Change the direction. 30-liter increments. You've had an overpressure event. Well, I can do it, got fixed. Nice. Wait. Do I have you the wrong way around? Nothing's changing. Now things are changing. No. I did in fact not have them the wrong way around. So, liquids that condense are being allowed to go in there. And this be Sterling. Barely acceptable. Right? Your pressure is actually increasing. Heckin' lovely. And you are losing water. Now, let's see here. Let's see. So if we look at these, we have inside here the condensation valve would allow for gases to enter a liquid pipe. The expansion valve allows liquids to enter a gas pipe. I got no idea if this will, get anything done in the way we want. I'll turn off your logic, so we can turn you off. It's volatiles. Pipe network empty. Temperatures are dropping ridiculously fast. Temps inside here are sort of okay, but I guess the cool shift from there is being a mild problem. Let's get the rent. Minus 136 inside there. Freezing CO2 and pollutants. Huh. So I guess things freezing inside here aren't actually that big of a problem. Handy. So put you there. So these pressures are still being shucked out. This pipe
Deal
network.
snowy, man.
Ooh, that's joking. Hey there, game potato. Let's see if we can get this nonsense. Oh. I ran out of pipes. So what if we flip you around there? Water pipe. Okay, and then grab these, check the time. Alright. They're working, potato. Won't be too long now. We were supposed to be working on our solar panels today, but now, well, now we're here doing this instead. Let's see here. Condensation valve. Then we'll do that. Do that. Remove that one. Remove that one. We do that one. Nope. And we okay, so there is a lot of H2O, being, well, lots, but you know, it is turning into the temperature's almost at 200. That is amazing. Okay, reach the purge state. Turn you on. Well, that didn't really work out. Unless... Did we have normal, boring ass liquid pipes? We do. So let's see, will this explode the entire thing? Looking in here, looking in the back of space. There. Okay, now temperature is going down from 1900. And that should allow the liquids to pour out. It's only 0.45 moles, so it shouldn't be too much of a problem. At least this way around, the ship won't directly break. It still has almost 7.5 kilomoles. Okay. The pressure's growing up. You have the very little left in you. Oh, the whole thing was off for a little while there. We should have more water now. 111 liters. Now, let's have a look-see here. One final little experiment need to be done before the day is done. And that is that example of absolute nonsense that we heard from freaking Baleen and Lamaine. Okay, we can't put it there. We need a... So this one... Oh. They're like, oh, we can't put it like in the middle of floating in the air, but apparently we can, so that's fine. Now we got water on one side, gas on the other. See? Heckin' stonks. Perfect. Then... we do some risky business with that. We open up this one. We use the wrench. Reattach that liquid tank. And... let's see about... mucking about with these bad boys. What kind of nonsense is increasing? Closer look at the details. Water and steam. But none of the others. Right. But Now the problem is that one, of course, yeah. And currently this one also then has steam being pumped in here. And that's okay, because the steam is also being turned into a liquid. Which means the same steam at 396 Celsius is being then slowly but surely being pumped in there. I was thinking that if we put in other things, you know, we could then try to like pump out the gas because we have the gas in another container. But I think we'd have to get a more sensible setup for that to work. Now, alright, mega maxed out. Checking the pressure situation. Temperature is there we go, now it's cooling down. Oh, wrong one. There. Okay, pressure here is slowly but surely increasing. You're doing your best, you're doing the best. This one might break. Eventually. I don't know if 0.45 moles is enough. Liquid. But with enough valves here in between, it should be fine. 7.1 kilomoles, so if we just leave it on, it'll actually... well, we'll get done eventually, I guess. Morning and come no explosion. Hello there, no hypocrisy. Hope you're doing well. Hope you're doing well on the YouTube side. Mild annoyance about the pipe, but now they'll be fine. So the megapascals are now at 47. They're approaching 40, which would allow for there's enough time for this thing to get a little bit extra moles inside. Temperature is nice and high. And eventually, this shit'll cool down enough. 275, so at 200 degrees Celsius is another thing. Purge event, which shouldn't take too long. Seaman water is already gone. That one keeps on increasing. Okay, let's do pipe network. Yeah, now the power's low. Getting there. Oh, I'll be on for 8 hours. Oof. I need to go walk those doggos. I hate when the stressed pipe noises are actually damaged wall noises. Been dealing with that on my furnace. Ooh. You're giving me new kinds of fears there, no hypocrisy. Whole new levels of fear. I'm trying to make sure that the pressure remains above 40 megapascals. All the way to 200 degrees Celsius. There we go. Set that direction correctly. We should probably set those as well. There. Now this thing has turned off proper. And now we wait for there to be no more water or steam inside the pipes. And once that is achieved, this will go. Now, the pressure ain't too high. How dare you complain at me? Condensation's happening. You know what? That says A-OK, because we got our drain valves on all sides. 1.2 liters of water. Jesus Christ. Oh, because the temperature got so heckin' low. 102 liters in here. 13.4 liters in there. Now, that one was just a funny experiment. It just kind of not fucking worked.
Party had happy affiliate anniversary.
Hi there, Zillion. Thank you very much. I appreciate it. Temps of 199. Machines have The automation is functioning. Everything is working as intended. Surprisingly large amount of liquid inside, but that's okay. It's all getting drained. I should unplug this thing from the system. We'll figure that one out eventually then. Pressure slowly going down. The water is well, slowly but surely getting in here. Yeah, it's gonna get rid of these gases. But yeah, all the water here is now liquid, which is good, because that is what we wanted. Combination of pressure and stuff. There's very little steam in here, which most likely will not be continuing for a long time. Boy howdy does putting the furnace in a box increase efficiency. It's almost no pressure. It says hot enough to smelt tier 1 and usually tier 2 alloys for easily 20 real minutes. Holy butt nuggets, man. We'll be getting there myself as well, eventually. Okay, so now this one has many moles of pressure. This pipe got drained. Now the pit system is maintaining that pressure. All of these got reactivated, and this logic is maintaining these pumps, making sure that there's enough steam for everything. And if things should no longer be cooling, it turns off the Stirling engines to no longer cool it excessively. Where this one is checking that, do we need more steam? Is the pressure there below 50 megapascals, which it sort of constantly is, thanks to the system eating too. I almost feel like maybe I should make a second one of these. Sort of emergency liquid thing. It's doing something. And also check, do we actually have any volatiles left? And if we have volatiles, then, and that could fit some more steam, activate the mixer, activate the burner, and they're off. one-way valve to make sure in case this thing starts cooling shit off too much. If something has to burst, it'll be this one. Which I thought would happen because I saw the things inside the machine cooling down so much, but it turns out things inside the machine can get pretty frosty to the level of freezing and not actually burst. So the pipe outside was doing okay. So I was over worried. Didn't need to. A little bit of stress, but nothing we need to worry about. Whomp. And in here. Hey, getting beautiful. And almost all the pressure gone. It's going to take a while because every time it cools down, you know, things shrink and the pressure goes down with it. And we're just not getting the pressures we want. Yeah, definitely looks like we have, with 4 Stirling engines, we could definitely put one more of those bad boys. It'll burn through the volatiles faster. At least we'll maintain some kind of pressure for these guys. And now we've got 100 liters of water here. Plus some other gases we're kind of trying to get rid of. Ooh, is the pressure going up? Or why is the water evaporating now? I mean, temperature going up, pressure going down. What? I'll stop that one. I've been trying to remove some gases from here, but maybe... I think the pressure might actually be increasing here. I mean, the temperature. I'm not entirely certain why the water's evaporating, and then the pressure got too low. So I've been trying to pump out those gases. Mainly the pollutants. So I guess I could... link this one back in. Now let's get past it to 790 liters. Got 13 liters inside. As I was like just mucking about, experimenting with shit. But also, if we just let it run, even though it fills with steam, that's a-okay. Because, well, there's more of it. And that means that eventually there will be more. And more, you know, more pressure. Which will force it back into becoming a liquid. Well, these are very inefficient right now, to be honest. They're producing power, which is nice. Because we kind of ran out of power here during the day. Yeah. Each one of these could producing kilowatts worth. 2 of these could burn through a normal cable already. Yeah, I need those cable analyzers and have a look at the batteries and their logics and figure out, so have a nice visual to display somewhere for how is our power situation actually doing. And then it'd be interesting if we would be able to differentiate where the power is coming from. Like if we had these guys feeding like a battery in between, and that battery then fed into the rest of the battery network with a transformer in between to make sure nothing really explodes. Now you're running out of power, and there's wind power in batteries. I'm guessing it's the centrifuges and my crappy logic controlling these, which never turns them off. And wind power, yeah, it depends, because usually my wind power is all completely filled out the batteries when there's been a storm. But I've been building the base bigger and bigger and bigger, and I haven't really increased the power out creation yet. And I guess I just had a long time between storms and calm weather. So I guess I was just unlucky. That's why we've been so supplementing by, well, building these things. Oh, and also as a way to just, generate more water. And there is, of course, the mountaintop. Oh. It's not on. Why are you not on? It should be on. Yeah, so the auger finished. With that, we already know where this tunnel goes all the way to the front, and it takes a right, and it comes out of a mountainside, and right there we're gonna build a second outpost because there's iron, copper, and silicon, and also nearby silver, nickel, and lead. At the moment, I'm 10 wind turbines and 2 nuclear batteries. No issues. I live between storms. Yeah. I've been surviving like that for quite a while, but I guess just in between the storms this time, it just took surprisingly long, pretty much. Now, speaking of nuclear batteries, not that one. That one. But an empty one. This one is charging, so this will eat a lot of power. But it's gonna be a-okay. Nuclear station battery mod. Ah! Without explain it. Hacking mod users. Yeah. If if I built more large batteries, I think I'd be better off. Because then they would be, well, it's a bigger buffer because the storm generates so much power. So being able to store as much as possible would be lovely. So I need to build more large batteries. Need to get the large solar array functional, which was what I was supposed to do today, but instead we fixed the Stirling engine, which means, hey, no regrets. It was super awesome. I'm glad I did it. I guess then the next time we'll have to then focus on the solar, because right now, the Stirling is doing just fine. The liquid the gas situation would be nice to fix, but no rush on that front. Frankly, I was thinking maybe I should just put another tank. Heck, let's just do it now. Because I want to test a theory.
Hydration critical.
Nah, they'll be fine. We were much worse state when we started the stream. And much further from base. I'm like so happy the combustor is working so well. All of this now automated. With 2 separate chips maintaining separate things. And a nice on-off switch for the Stirlings. So, now I have automatic water production which produces power on the side. Heckin' aim. Wonderful. Now, I need valves. I'm gonna steal that one. Now, that one didn't really want to work. That weird experiment of mine. Let's see. We'll need to remove that one. We'll need to have a look. Oh, nice. It's fine. Just a wee hongy. Insulated tank. There we go. Then we have the this one.
Power critical.
Okay, 10% is maybe a little rough. There we go. And the power will actually kill us, so... There we go. Now where's that heckin' cable? Don't you dare... You bastard. Alright, easy enough fix. We put those two there. And we do that. You go away. Come on, come on, come on. And yes, I've been on my, like, just one last final experiment for quite a while now. Could you feckin'... What? Goddamn pressure regulator. Alright. Much faster. Interesting. But it's not really solving a problem. Yeah. Barely maintaining that pressure and temperature. And now this will give more chances for this thing to actually build up some pressure, because this final sort of approach to the 200 degrees Celsius while maintaining a pressure of 40 megapascals is going to take a while. That's okay. So now I got to go get our dude. Ah! Heck, Jesus. Gotta say, yeah, the hard suit jetpack is a lot more powerful than you would expect. Any outposts yet? I mean, I've got my two deep miners, one over there, one over there inside the mountain, and then there's the solar array that needs to be built on top of it. So whether or not I have outposts really depends on your definition of an outpost. I just build these giant chute networks and cable networks there.
Hunger caution.
And there we go. Schematic space hygiene. There we go. And I do is doing pretty okay. So we have our Stirling engine functional, the entire system automated. We just need to, find more volatile ice and keep that volatile tank filled up. and the entire thing will, well, run on its own. I'm hoping that with the sort of prolonged slowdown in the end, because it's pumping such a small amount, so maybe that one H2 per combustor might be enough. So yes, the iron, copper, silicon deep miners. Not yet. I have the location and I have the access like tunnel to there. I just didn't get around to building them just yet, because the plan was to first make sure we have a stable power source with the solar array. But then I got distracted by those guys, the Stirling engines. So that's nice. You're absolutely correct, Game Potato. That's sort of what I'm trying to do here. So, iron, silicon, copper, silicon deep miners will be in the next episode of Hunt Goes to Space, which will not be today, because I need to go walk those doggos. I've been on for more than 8 hours, and tomorrow will be something. I haven't really decided yet, because tomorrow's the sort of affiliate anniversary, all officially, like, even though apparently people can be saying, oh shit, god dang, I completely missed you, I'm so sorry, Pythos, I won't want you to, and thank you very much for the congratulating on the affiliate anniversary. Ooh, and a 7-stream streak at that. Heckin' wonderful. Thank you, Pythos. Man, I feel embarrassed. Been like 6 minutes since you said that. Oof. And I'm sorry, goodbye, Hanno, have a good evening, time to eat, tomorrow work. I was too lost in the sauce. And thank you for hanging out, Knapsar. I really do appreciate it. I'll be seeing you around. But yeah, I gotta look for someone to raid too, because those doggos do need their poopies. And also, I need to feed. But man, did not achieve anything of what I was supposed to today, but I still achieved a lot, so I'm okay with it. Yeah. Stationeers tends to do that. I get absorbed sometimes. Ooh, yeah. Gotta say, I absolutely love the game. And its ability to do that. To really just, whoop. There we go. Ooh, sorry about that. Goes up, yeah. Thank you for your understanding there, Pythos. And I'll have to try again harder next time. But that will be next time. Because yeah, we're gonna see who is out and who is about. And what are people playing? Also see, is there anyone I know playing this one? Nope. Now we check our following numbers. What are people doing? What are they up to? I mean, other than apparently everyone's playing My Winter Car, which is fun. It is true. But you know what, why not? Let's just do a nice little wild dash straight into the wild Swiss, the bluest of orcs. It is the Twitching himself who's doing games and demos currently, and he's trying out Fear and Hunger 2, which is a very interesting and different kind of game. A wild one. Now, the Torque is always a good time, and I hope he'll be entertaining you as well. Give him my best, and of course, if we're doing this, we need to look at this goddamn playlist. There's a special song we all know and love for this very occasion, and it is, of course, Drink and Industry. God, I love that song. Right. And says a lot of mining. Oh yeah, no hypocrisy on the YouTube side. I absolutely agree, and that is very much is an important goal. Getting those final deep miners out there, getting that iron, copper, and silicon. Oof, it's gonna be amazing. But that'll be at another time. Thank you, friends. Thank you everyone for coming by and saying hi. Thank you to all the chatters, all the lurkers, and all those that just wandered on in. Hope you had a good time. I had a wonderful time. From all of you. And I hope all of you have a wonderful day. So, until next time, my friends, stay awesome. And I gotta try to remember to actually push that goddamn raid button. It usually helps. Yeah, thanks for hanging out, everyone. I really do appreciate it. Gosh, 1 year since I made a affiliate. 1 entire year of streaming, and then some. been a good time. Thanks for hanging out, everyone. And thank you for, helping me do this, letting me do this, and supporting me by just being here, watching the stream, being, apparently enjoying it, and hopefully having fun. So, I'll be seeing you around tomorrow. Again, a couple of hours game dev. We'll see if we can get those data structures we were trying to invent today into action. And after that, we'll be playing some games. I'm not sure what. Most likely, let's be honest, it's going to be Stationeers, isn't it? But I don't want to promise. Not just yet. Ooh, you'll have to tune in tomorrow to find out. Now, until then, my friends, stay awesome. Ta-ta.